guys, welcome back to Rocket Gyan, my fellow space tubers. And first of all, sorry for the delay that happened. I hope you can hear me properly. But yeah, I was searching for this, this lucky sweatshirt of mine. I wore this during the Chandrayaan 3 landing, and today also I wanted to wear something which will bring that lady luck to us to witness today's lunar landing on the south pole of the moon. And I am really excited. And don't worry guys, you are with me, you are new to this channel, or you have been following this channel. Let me tell you, you just have to sit back, relax, and enjoy this whole coverage of live lunar landing. And I will be your host and telling you each and everything that you need to know about this landing and about this mission as a whole. And I hope you will guys enjoy it. So first of all, okay, yes, the lunar landing, yeah, first update is the lunar landing was delayed. Okay, it was supposed to happen at around this time only, but it got delayed. So what they did was they actually decided that the spacecraft, the lunar lander, which is the NOVA-C, which will orbit the moon one more time before they will start attempting the landing. Now why they did it, they haven't revealed that, but to be honest, in my past experiences and all, we don't see delays in the landing unless there is some space weather issue. Yes, there is a thing called space weather, but if there is a delay, that means some sort of technicalities or some technical issues are there. But I am hopeful that it was just to make sure that additional checks, they wanted some time to do some additional checks, and hence they were there. So without any further ado, I'll just jump into it and see what all things we have for this mission. Just give me a second. Yes. Okay. Hey Nicole, hey Surf, hi Wildflower, hi Mars and Dever, and Action Film Works. So I hope you all guys are will be enjoying this stream, and welcome. And we also have KS, Baba Yada, and yes, our all-time attender, Wildflower is there. So let me just jump into this, what this lunar lander NOVA-C is all about, and what this intuitive machines is all about, right? But before that, if we are celebrating something, we should not forget the sacrifices of the people who have fallen, right? In this case, it will not be people, but another spacecraft, which was this. This was the spacecraft which attempted a month ago the lunar landing. This is the Peregrine lunar lander from the Astrobotics, and this also tried to attempt the lunar landing, but it was unable to even go to the moon because some leaks on the fuel tanks happened, and that was an unfortunate event. But yeah, all sacrifices lead to a successful outcome. So this is one of those. So with that out of the way, now let's have a look at the NOVA lander. Hey Matt, how are you? Hi Simon, I hope I may fell asleep before it lands. Simon dude, here right now it's 2:44 a.m. So I might fall asleep before it lands. That statement should be coming from me, but it's okay, I can understand. Yeah, touchdown is now scheduled at 11:24 GMT. Yes, Robin. Hi Matt from Ireland, good to see you. So intuitive machines is nothing but, so first of all, this landing is, people who might be wondering, well, this landing is not being done by NASA. This is a private company, which is the Intuitive Machines, which is going to do the lunar landing. And yes, NASA have helped them with all those science equipments and other things, although the technology and everything they have to master by their on their own, but yeah, the instruments and everything which could assist the landing, they have provided that. This is a part of all the NASA's CLPS clips, or the commercial lunar payload services or program. That is like, the full form is not so clear right now, but yeah, the CLIPS program. So this is part of that. The Peregrine or astrobotic lander was also that only, but yeah. So intuitive machine, what this is all about. So intuitive machines is we have, yeah, they have this tagline, from napkin to the moon. Why do they have that? Because the CEO of this company, actually, you know, when they first of all, this company is a very old one. I think it was founded in 2013, if I'm not wrong. And this the idea for this company and whole concept for this company came to the CEOs, the founders, when they were having a chat on a dining table, and then this idea struck, and the founder, the CEO, has actually just wrote everything down on a napkin, like what all things they will have to do, they'll need to do. And yes, that's how this company's tagline became, from napkin to the moon. And yes, literally they are solving each and everything related to the lunar service. They are literally tapping into the lunar economy, which is the cislunar economy. If Artemis is going like it is going right now and it's successful, then you just see what happens in the next decade. So this this actually provides end-to-end services. So lunar access services is there, the rideshare Micronova, which is nothing but Micronova is nothing but another lander only, but a smaller size. Rideshare, again, you can put on all your science experiments or other things, payloads basically, on their lander, and it will take that to the moon. Then we have the lunar data services. Literally they are providing the data services, which means they will try to establish a lunar network sort of things, so that all those data related stuff, like the connection related stuff, if you are on the moon, you should not have to worry about that. So all those things they will be taking care of. So they are very ambitious in all that, and they have not rushed their spacecraft and the lunar land, and that is what I like about them. So we have a, you know, what should I say, a good amount of time, a good amount of research and development which went into this. So I am actually rooting for this missions to be successful, and somehow I feel, this is my gut feeling, that this will be successful. Then they have the space system and services, which means they will not only the lunar related stuff they will do, but also the space infrastructure, which means anything related to space, the satellites in the low Earth orbit, and all those things. So any services related to that, everything is there. The orbital services, space systems are like, you know, again, you are providing a satellite bus, you can put in a payload and then they will launch it, something like that. So that is the case. And today we need to talk about what? We need to talk about the IM-1, which is the lunar NOVA-C lander. And don't worry, we will have a look at it. So okay, 9:15 in the UK. Okay, cool. All right, so let's jump into this and see what this lander is all about. So this is how it looked when it went to the orbit. This is just the, you know, what should I say, the last photo which they took, which is, I think, and I'm not sure whether this is the last photo which they took, but this is the last photo which is available to the public when it went, before it was encapsulated into the fairing and went to space. So this is the intuitive machines, and what this mission is all about. This is nothing but IM-1 for short, this intuitive machines mission 1, that is the thing. And it will showcase the maiden flight of company's lunar lander. It will be, first of all, the major you know, upgrade, or kind of what should I say, major thing, differential thing about this lunar lander is that it is using cryofuels. And cryofuels means when you see those SpaceX launches, right, those vents, those gases which comes out, all those things are the cryofuels. And this is going to land using a cryofuel, which is highly unusual when it comes to space exploration in the case of spacecrafts which are trying to go into the deep space. Okay, so mostly they use earth storage storable liquids because they are easier to handle and they don't need to worry about the boil off and all. But again, this mission and this private companies trying to do a practical thing, because in future when the spacecrafts or other landers will go to the moon, they will utilize the cryofuels only, which is hydrogen and liquid oxygen in that case in the moon, because that is water is available on the moon. You will split those hydrogen into and oxygen into that, and then you can use that as a rocket fuel. So we need some sort of, you know, kind of what should I say, practicality over here. So they need to test everything whether it works or not, and hence they have went to for the cryofuels. But that is not the liquid hydrogen, liquid oxygen, but methane and liquid hydrogen. And why methane? Because methane is the fuel, rocket fuel for the solar system. It's kind of available everywhere. So that is the case, and it will be an what should I say, this was a part of the commercial lunar payload services, and we'll go into the things related to that. But before that, I wanted you to see so basically the intuitive machines, as I said, they want to achieve the lunar surface access, lunar orbit delivery, communications at lunar distance, all the things related to lunar services they want to do, and that's what they are going to do with this. And today the NOVA-C lander, which is going to land, and this NOVA-C lander, the C stands for the Roman numeral 100, and C literally 100 is there is a reason why they have this 100, because 100 kilograms is the payload capacity which it is taking towards the lunar surface today. So that is why the C is there. And the spacecraft itself is named as Odysseus or Odysseus, yes, Odysseus or Odi in short. So they might call that when it is going to land, and what is the landing location, everything, we'll have a look at it. So now let's have a look at this spacecraft in a lot more detail, so that we can have a look at it. So basically this spacecraft is going to have a propellant, a total mass of around 1931 kilograms. It's the dry plus wet mass, but the mass of when we are not considering the propellants and fluids, which is the dry mass, it's around 655 kgs. So it's made up of all the carbon fiber structure, hexagonal. First of all, this is also something which you need to know. First of all, this lander was supposed to be kind of cylindrical, but then they changed it to hexagonal because they wanted to include more of the payloads and other things to it. And as you know, bees, you have seen the hives of the bees. It's not cylindrical, it's hexagonal in structure, because in nature and bees knows that hexagonal structure has the largest volume which you can get, usable volume which you can get. So that is there, that is the thing. And in propulsion, as I said, it's powered, it's using liquid oxygen, liquid methane as its fuel, and you can see the tanks over here. So this is the liquid oxygen and liquid methane tank, and here we have again two of the tanks are over here. Then we have the 3D printed engine, which is again we don't have much information about what this engine is actually. But what I think is that it is not a very complex engine. It might be a very what should I say, simpler engine. Again, not sure, they have not released it publicly what is the configuration of the engine, but yeah. So they will also be using this composite helium tanks, which you can see here, which is nothing but gaseous helium, which they will use to pressurize the tanks. And also like those gaseous tanks will also kind of acts as an RCS. So kind of, you know, yes Jim, basic engines, in space you don't need to have all those, you know, fancy engines, because basics works. You don't need that much of thrust in space, everything works. So yeah, you just need to focus on the ISP, the mileage of your engine. So yeah, so it will have certain pointing modes, which I'll also talk about. So yes, we have heat shield also. So here you might be wondering, why do we need a heat shield over here? It's not like it's plunging into the atmosphere. The lunar atmosphere, the moon does not have any atmosphere, right? So how and why do we need a heat shield on this? So the answer is, again, it's using cryofuels. They don't even want a single amount of heat which they can avoid going to the tanks. So engines is over here, and when engine is firing, obviously it will emit electromagnetic waves in the form of radiation, which is again heat. It will emit heat, and you don't want that heat to go to your tanks and cause the boil off you, because those cryo engines are at a very low temperature at -200 degrees or something, and so you don't want that. That's why we have a heat shield over there, so that the insulation is provided between the tanks and the engine. And then we have the navigation pod, the reaction control systems, and the solar arrays. So yeah, so this thing has various modes also to it. The solar pointing mode, the propulsion vector tracking mode, and the communications mode. So in the solar pointing mode, what it will do, you can see we have a solar panel over here. So it will point this solar panel towards the sun in such a way such that the maximum output can be generated using that. So that is the solar pointing mode. You can say that this pointing mode is kind of an ideal pointing mode, which they do when the spacecraft is not doing anything. So because this they have made it in such a way, because again they need to shield the cryo tanks from the sun. So they have placed the solar panel strategically over the top, so that if the sun is over here, they can point it like this over there, and you know, if the heat shield is over here, so it will point it like this. So the spacecraft from here is protected actually, and the solar generation is also happening. So again, something which is kind of intuitive, as its name is. So yeah, then we have a propulsion vector mode, which is again nothing but just pointing your vector towards the position where you want your maneuver to happen, right? So if you want to go straight, you just point to straight, and then you don't worry about your solar panels and all. You just turn on your engines and then go in that direction. That is the propulsion vector mode. And then we have the communication mode, in which it will point its communication array to the earth, so that communication can happen properly in a very fast rate. So that is the thing. Now we can talk about those all those experiments which it is having. So first one is the so we have a certain NASA payloads which is going. So first one is the Odysseus. This is the experiment which is name is the Odysseus. Full form is radio observation of the lunar surface photoelectron sheath from the Goddard Space Flight Center, which will be basically what it will do is it will try to understand the radio observations from the lunar surface. Okay, so what it will do is that we know that moon does not have its what should I say, the atmosphere, right? So any interaction with the lunar dust which needs consideration when designing future space suits. So using its 4 antennas, this Odysseus will measure radio waves from many sources like the sun, deep space, even from our planet, and all those things. So it will be using that to measure the radio waves and how the radiation from the lunar surface itself is bouncing or is interacting. So it will try to measure all those radiations which is going to be you know, from various sources, as well as from the lunar surface also, how the radiation interacts with the lunar surface and how it bounces off and all those things. It will, yes, sure, it will land in at that point of time. Then we have again the lunar retro reflector array, which is kind of like a pointer or a marker on the lunar surface. It's a passive equipment. It will just act as a marker, so for the future missions, when they are trying to land, they can use those markers to identify their landing site, as well as accurately measure the distance between the surface and the spacecraft. So that is that. And then we have this thing, which is the NDL, which is nothing but the navigation Doppler lidar for precise velocity and range sensing. As it again, this is an instrument for which will be used today for landing. So this is the lidar basically, which will try to guess the velocity and the distance between the spacecraft and the lunar surface. So it will be able to measure all those data, and it will actually help it. So then next one is the SCLPS. This is again from Langley Research Center. It is nothing but stereo cameras for the lunar plume surface studies. So what it will do is, its point, if the lunar lander is like this, right, it is pointed like this, these cameras. So it will try to get the landing video, and it will try to get not only the landing video, but also just see how the plume is interacting with the lunar dust, so that we can study it, because again, we need to know about how those things works when we are going there, so that nothing unexpected happens. So that is the case. And then we have the so yeah, this is again amazing thing which we have. Then we have the LN1. This is the Lunar Node 1 navigation demonstrator, which will function as a beacon. So this should be help to guide spacecraft arriving or leaving the moon by using S-band radio waves. How cool is that, right? This time, however, the demonstrator will only emit signal that NASA's Deep Space Network will use to obtain precise positioning. So this is kind of, obviously we are not sending it any another spacecraft right now for it to actually function like it, but again, the testing and all can happen, so that will happen. So again, one more thing which is NASA testing is the radio frequency mass gauge, which is nothing but a fuel tank indicator, fuel tank measurer. So for cryofuels, you need a different type of measurement of how much fuel is left, and NASA has developed this RFMG, which will be used today to measure the fuel tanks, the fuel in the fuel tanks very accurately. Then we have this is interesting. So now we are coming to the commercial payloads. So this is something from Columbia Sportswear, if you know about it. So the Columbia Sportswear is kind of, they are using this Omni Heat Infinity material. This is amazing, literally amazing. When you know, usually what happens, we develop certain things for the use in space, and then finally it goes what should I say, it trickles down and we use it in our daily lives. That is what happens, but here it's vice versa. It's reverse, it's Uno reverse basically. It's already there. This Omni Heat Infinity was developed for the thermal protection for the sports equipments. I'm not sure what is the use in the real world is right now, but they have already developed it, and now they are using that particular Omni Heat Infinity sheath to insulate the spacecraft from thermal radiation. How cool is that? So this is tailored to increase reflectivity and applied it on the external panel that will make sure that the cryofuels are in the optimum temperature and are insulated from various things, radiations, heats, and all those things. Amazing, amazing. And we have our showstopper today, the Eagle Cam. So today, when they will be landing, this little camera will hop out of the lander, and so what will happen if the lander is like this? It will release that camera, and the lander will be landing, and this will also be landing at the same time. So what it will do is it will take a first ever third person POV of the landing. How cool would that be? Just imagine that thing. Like, we can actually see how a lunar landing would look like in real world. not from a pointing cameras, but from third person POV. If a person is just on the side of it, it will be able to get those. So after that, it will just land on the surface, not crash land, but just hard land on the surface, and then it will be able to do it. So this is literally amazing. At around 30 meters from the surface, this camera will be deployed, and it will also test the electrostatic dust removal system, which is necessary for us to master this technology for future lunar missions. So it will also not only take the pictures, photos, and all those things, but it will also try to remove the dust from the lens if any sort of dust comes out of it, so that it will be able to take clear photos, clear images of the landing. How cool is that? Then the next commercial payload is this, which is from a Jeff Koons moon phases. That's what it is called. This is nothing but 125 miniature steel. Here you can see these moon phases sculptures, which will fly on the side of Odysseus, which will it's kind of an souvenir which we are sending from here to there. All the moon phases which we see on the earth will be there. So this artwork actually consists of 3 parts. As for each sculptor, another one remains on the earth. How cool is that? Additionally, a non-fungible token connects both of them. The names of individuals who achieved a variety of accomplishments in various fields are inscribed in front of each art piece. So again, a souvenir which is always amazing. So then we have this one, which is the International Lunar Observatory Association. This payload is known as ILOX. So what it will do is it's landing on the lunar south pole. So since it is landing on the lunar south pole, why not have a astronomical observatory over there? So yes, this is what it is. This main goal is to take the first images of the center of our galaxy from the moon. Additionally, it will also carry out astronomical lunar and earth observations, which will be like again, it's kind of astronomical telescope kind of a thing. So it will take the images, and it will try to explore the galaxy. It will try to explore the space from the lunar point of view. So again, this is something which is amazing. Then we have the Galactic Legacy Labs, the Luna Prize, with the collection of messages called Lunagrams. The overall goal is to preserve the human knowledge for eternity. So everything related to that, right? The text, images, music, video, all those things which are well preserved, so that some sort of, if something happens on the earth today, right, then if this kind of an archive, right, a time capsule kind of a thing, will be remaining on the lunar surface, so that it will be remembered by the aliens if they will find us, right? Some civilization was here and something happened to them. How cool would that be to do all that investigations and all? T minus, it refers to the time remaining for the official countdown. Actually, no. You are right about that, Jim. This is the time remaining for the actual landing, but I will change it, don't worry. So yeah, thanks for reminding me about it. I will change it, so don't worry about it. We'll get that. Okay, so yeah, this is the lunograms, and it is having all those archives to it. So finally, yeah, so this is what we have um, for all the payloads which it is having. So talking about all those payloads, placement, here you can see the Rolls' antenna is over here. The scalps camera, as I said, it will be pointing down and try to film the plume, interaction of the plume with the lunar dust. Then we have the NDL sense laser over here, which is nothing but the LiDAR. Then we have the ILOX, the space observatory. Here we have that, this one. Then the LN1 and the another ILOX. So all those things are placed over like this over here. Then we have this is what I was talking about, the commercial lunar payload services CLPS program. So this is a program which allowed, since it was announced in when it was announced, right? So it actually encouraged the private sector to make certain improvements, certain innovations, certain things for the lunar exploration. So it is like previously when Apollo mission happened, it was only funded by the government agency. Today the Artemis mission is going to happen. It will be actually be driven by the government agency, which is NASA, but it will have the support of the private entities also, so to encourage them to build certain innovations in space, certain helper things. We had this lunar payload services program, or the CLPS. So the Peregrine lunar lander as well as this one is a part of this. Now let's have a look at finally we have talked a lot about all those things related to the lunar lander and what it has. Now let's talk about this thing, which is the mission profile, which is how it will do the landing. So it will right now it is in it was, first of all, it was in 100 by 100 kilometer lunar orbit. Right now it is in 10 by 100 kilometer lunar orbit. So at the south pole region, which is over here, it is at the 10 kilometer, which is the periloon. Then at the upper the north pole, it is actually the eploon, which is around 100 kilometer. This is the descent orbit, which is the thing, descent orbit insertion and this thing. So this has already happened. Now we are waiting for this power descent initiation to happen at 1618. Although this is like the older timings, now it has changed. Okay. So the changes are like this. So basically the landing is going to happen at 1724 central. So all those things they have kind of made an hour or so further. So yeah, we have the power descent initiation at 1618 CST, then pitch over with main engine, which is over here. So terrain related navigation will happen first of all. So what is that? Basically it will turn on its cameras and it will try to filter out, try to take images of the below surface and try to see where it is right now, and wherever it is, it will try to figure out, okay, this is how far I am from the landing site by taking those images. And then again the software will do the optimizations accordingly and make some corrections over the landing trajectory. It's like that, and it will know when to initiate the landing of the mission of the lander, basically by taking all those images. And then finally power descent initiation will happen at 1618, almost like half 1 hour after that. Not 16, you forget about these numbers because these numbers have changed now, but yeah, that after 1 hour that is going to happen. And then 1618 to 1628 will have the pitch over with main engine, which is this one. So what does that mean? This means that all the horizontal velocity, which you can see right now here, right, horizontal velocity, because it's going in orbit, that will be cut off, that will be cancelled out. So all the horizontal velocity cancelled out, but again the gravity is pulling that lander down, right? So it will have to cancel that also. But it right now in this mode, this phase, basically it's just cancel out the horizontal velocity so that it becomes vertical, and then after that pitch over with main engine, which is over here, it will become vertical because now it does not have to cancel any sort of horizontal component of the velocity. Hence it can it will basically, what it will do is this thing will be just above the landing location. Okay, now it will try to do the hazard detection and avoidance, which is again it will see if any boulders and anything is there on the lunar surface. If it finds something there, then it will do the avoidance maneuver by again all those algorithms and other things are there loaded in the lander, and it will do that. Then finally the vertical descent will happen after that in 1 minute, and third terminal descent, and then finally landed. So power descent, from power descent initiation to landed, you can see it's a 12-minute journey. So I will accordingly change my timer also, so you don't have to worry about it. Let me do that right now only. Yeah, now it is corrected. So now the timer is when the countdown for the landing will be initiated. So T-1 are 26 minutes are left. So yeah, so this is how it will land. This is something which is followed by almost all the agencies around the world, and this one again, the Chandrayaan 3 landing which happened, right, it was also sophisticated, although this maneuvers which they have given is very, very simplified. There is a whole lot of complex things and complex phases which goes into place, but yeah, this is like what all kind of lunar landers follow, that they first of all cancel all the horizontal velocity, then do the hazard avoidance maneuver, and then finally land. So yeah, this is what it is. Now where it is landing, we need to know about it, right? So this is the moon, and this is the image which is provided by Jatin.space. You can check out his blog. He has this Moon Monday articles, and those are literally amazing. So if you want to learn about what is happening in space in general, if you are into reading stuff, check out his blog. Amazing guy, amazing talent. So today yeah, so where it is landing, so this image is for the Chandrayaan 2 and Chandrayaan 3. You can see the Chandrayaan 3 has landed somewhere over here, right? But the lunar lander today, the NOVA-C, is going to land over here, which is more towards the south pole of the moon. So it's around, what should I say, if it is from Chandrayaan 3, if the center is from here, we calculate from here, then it was around 600 kilometers from this point. Today it will going to be landing around this location, and it will be around 300 kilometers from the south pole. So much closer to the south pole, that means lot more boulders it will be having. And why they have chosen this landing site, first of all, the landing site is the Malapert A crater, somewhere over here only, in which will be landing. So basically they have chosen this landing spot because they wanted to demonstrate that they want to land over the place where actually the future astronauts are going to land. So as much close to that possible as we want, they are going to land over here. So which Starship would launch already. I hope that would be the case, but that is not the case. So hopefully, but again, the Starship also has its lunar version, and that will actually take the astronauts from the gateway to the, if gateway is still there, the Artemis gateway is still there, from gateway to the south pole of the moon. So don't worry, Starship will also come and take its share of what should I say, contribution. So yeah, so this is where it will land now today, 80 degrees to the south, somewhere over here. So that is the case. Now next part, okay, let's see some images which our NOVA-C lander has taken. So this image sorry, So this image is taken from the near side of the moon, which is the side of the moon which we can see, and here you can see the kind of a selfie image, and you can actually see all those components which we just discussed. This is the the gaseous hydrogen tank, so not hydrogen, the helium tank, which is over here. The landing legs are over here. Also talking about the landing legs are also interesting because we have the team who worked on the development of the NOVA-C lander. Those names of the members of the team inscribed over the feet of the lander, so that once it touches down, all the names will be inscribed over the surface. How cool is that? So man, this is amazing picture we can see, right? And this picture, which is like, you know, that means they have a very, very high quality camera on board, and I am looking forward to much more pictures. Yes, there were many pictures before this also, which is which I will talk about, so don't worry about that also. So Intuitive Machines, hats off to you, you are doing amazing. And one more thing, here you can look out, this part is what? This part is, if you can see, we just discussed about this. This part is those 125 lunar metal lunar phases, right? The spherical metal balls from John Kepps, if I pronounced that all right. But yeah, this is the commercial payload which we can see over here. So amazing picture, amazing moon in on the behind this spacecraft, and we are just wishing that today is the day when NOVA-C lander actually lands on that particular grayish ball kind of a thing. Okay, then we have certain more images. Here you can see this is what this is one of those images which when it was on the around the earth. It's around the earth only right now, but again, yeah, when it was launched by the Falcon 9 and released for the translunar injection. So here this also have a this one wide field of view camera, which is also amazing, right? Here you can actually see the Falcon 9 second stage. Wow, I did not see that. We can see the Falcon 9 second stage from over here. It feels like they have launched the Insta 360 in space, and now we are getting those images. This is like watching a rocket land for the first time. How long is the spacecraft expecting to perform after it lands? That is also we need to discuss. I'll discuss about that, don't worry. So yeah, here you can see the Falcon 9 second stage, and obviously our lander is over here. Again one of the image where we can actually see the kind of the whole earth, so much more above the earth. So that is the case, and again this is again one of those images where you can clearly see our this is where I live, this is where you all live. We need to protect this beautiful planet of ours. This is only where the life as we know exists in the whole universe right now, because we don't know whether life exists. We haven't found evidence of life anywhere, so we might be the only one or we might not be. So amazing. This just, you know, opens up a lot when we actually see this, and if we get to see a chance to see this actually from our eyes, next level. And this is something, there is a term for this, you know, which is known as overview effect, and this is something when astronauts realize this thing always when they see this blue ball, right? Like this is so delicate, so fragile. How can we do all those things? There are no boundaries in space, right? Someone like suggested also, like we should shoot up all over the all our politicians to space, so that they can have a look at what it is where they are actually living and how fragile it is. So yeah, uh so yeah, let's move on to the next thing. Yeah, okay. So now we have discussed almost everything what I wanted you to see. This is summary of everything, not summary actually, in detail of everything which we just spoke, but in more of what should I say? You should read all this mission maneuver overview, the engine commissioning, the autonomous commissioning, because they have given each and every detailed step on what they are actually going to do on all those things. So that is amazing. And one thing, during the lunar orbit, so right now it's in the lunar orbit, right? But it can't stay in the lunar orbit for long. Let's say right now, if some issue was there, that's why it got delayed, and still they were unable to sort. But they can't stay in orbit for too long, because first of all they are using the cryo fuels, and fuel boil off is going to happen, and the amount of fuel which they will be having for the landing will then decrease, which they don't want. Secondly, in the lunar orbit, not only they have to worry about the solar radiations, but also they have to worry about what we call as an albedo, which is nothing but the radiations coming from the moon, the reflected from the moon. And that is something which is so basically in the lunar orbit, not only it has to shield itself from the solar radiation, but also from the lunar radiation, and it is having cryo fuel, so it can't stay up for long. Third, if they stay in the orbit for long, the landing location which they are aiming for right now will not be in the line of the orbit, and they will not be able to land in that case. So they have very limited orbits in which they can land. So yeah, that is the case. Wait a second, where was it? Where were we? Okay, we actually did not see this one. This is also one of the images from the North Pole. This is image of a North Pole which was taken by the NOVA-C lander only. So that is the case. And what I wanted you to see is this one. Yeah, I'm switching over to that. Don't worry. This thing. NOVA Control Center was designed to resemble Star Trek's USS Enterprise bridge, and yes, you will see that happening today. And all those wirings and all is a mile long, in more than a mile long, which is used in this one. There are certain interesting facts, so which we can see. But yeah, I think that should be it then. Okay, let me switch over to the stream. Have it? No, it has not started. We still wait. Okay, it has. Just a second, guys. Give me a second. I'm just preparing that for you. Okay, where is it? Okay. All right. Here you go. And switching over to in 3, 2, 1, and here you go. Why can't I hear anything? Guys, can you hear? Let me check. Wait.
Attempting to land on the moon to return the United States to the moon for the first time in 52 years.
NOVA-C uses an environmentally friendly mixture of liquid methane and liquid oxygen.
Incredibly challenging thing like landing on the moon forced us to innovate.
Intuitive Machines has built an entire space program to support these CLPS missions. The company completed its lunar lander in a new facility at the Houston Spaceport, just down the street from NASA's Johnson Space Center. It's an autonomous NOVA-C class lunar lander named Odysseus.
Lunar lander arrived at Kennedy Space Center in Florida back in December. Since then, teams have been integrating the spacecraft to Falcon 9's second stage in preparation for launch.
Go IM-1 and the Odysseus lunar lander.
Falcon 9 has successfully lifted off from Pad 39A at Kennedy Space Center. An incredible sight to see.
Odysseus
All right.
Lunar lander separation confirmed.
Our NOVA-C Lunar lander has successfully separated from the second stage of the launch vehicle, autonomously commissioned, and made first communications contact with NOVA Control.
Our approach for landing is actually very similar to what Apollo did, which should be no surprise because the physics are very much the same.
Let's honor this momentous milestone and prepare for the challenges and triumphs that await us on our lunar journey.
And we have
a live look into Intuitive Machines' NOVA Control in Houston, Texas, where flight controllers are preparing to start the landing sequence for the IM-1 mission. Our mission and activity directors are sitting closest to the large monitor inside NOVA Control, and they're supported by 10 additional flight controllers surrounding the circular Mission Operations Center. Good afternoon and welcome to our coverage of the descent and landing of the IM-1 mission. I'm Josh Marshall, Communications Director of Intuitive Machines.
And I'm Gary Jordan with NASA Communications. This mission is one of the first under a task order with NASA's Commercial Lunar Payload Services Initiative. Under Artemis, we're returning to the moon to conduct groundbreaking scientific discoveries and technological advancements. And this mission with Intuitive Machines is helping us to get there.
And Gary and I are at Intuitive Machines' facility here in Houston, just down the street from NASA's Johnson Space Center. Right now, inside NOVA Control, flight controllers are monitoring our NOVA-C class lunar lander named Odysseus ahead of its autonomous landing sequence that begins with powered descent initiation at 5:11 p.m. Central Time for a landing time at 5:24 p.m. Central. Right now, they're keeping an eye on the room's situational awareness tool called the Viz, which you can see on your screen now. The Viz is casted onto a large television in the front of Mission Control, so the activity director and the mission director can have the best view, Gary.
And the Viz is an animation representing real-time telemetry data feeding into NOVA Control. NOVA Control receives the data, runs it through Unreal Engine 5, and generates a visualization of the data. It's a useful tool for situational awareness and keeping track of what flight controllers expect NOVA-C is doing in space.
Amazing.
The white line points to the moon. The blue line is the past and intended trajectory. The yellow and red lines are pointing towards the sun and Earth, respectively. The different color cones you see at the top are the antenna arrays used for line-of-sight communication back to Earth. We'll show the Viz periodically throughout our coverage, up to about 12 minutes prior to landing. In these final moments before landing, the most reliable spacecraft data will be relayed through NOVA Control audio loops.
And we're starting our coverage later than expected today as flight controllers continue to assess NOVA-C's trajectory, guidance, navigation, and control. NOVA-C maintained a low lunar orbit, but is in a slightly more elliptical shape. Last night, flight controllers performed a lunar correction maneuver burn to adjust the lander's orbit. This burn kept NOVA-C on a trajectory to land in Malapert A, but moved our landing time estimates earlier by about an hour. Then today, flight controllers chose to exercise an additional orbit before starting the IM-1 mission landing sequence. This decision brought us to now, projecting a landing time of 17:24 Central Time. Intuitive Machines made the decision to reassign the primary navigation sensors from Odysseus's laser range finding system to use the sensors on NASA's navigation Doppler LiDAR.
This is a dynamic situation, and we'll update you later in the broadcast. Intuitive Machines still intends to land in the optimum lighting window, and the lunar correction maneuver performed last night eliminated the need for the planned 10-second deorbit initiation burn, which would have brought NOVA-C from low lunar orbit into the descent phase. NOVA-C's current trajectory has it continuing to decrease its altitude over the next hour until the braking burn called powered descent initiation.
Again, the landing time is expected at 5:24 p.m. Central Standard Time, 6:24 p.m. Eastern. The countdown clock at the top of your screen is counting down to the time that we expect to remove, and we expect to remove the countdown clock approximately 2 minutes before the landing opportunity. Getting to this moment, Gary, has been quite the journey, and it's lasted about 7 days so far since liftoff from Launch Complex 39A at NASA's Kennedy Space Center.
So that clears up, right? So basically that the countdown which they have is actually the one which is what should I say, it's not the countdown when the initiation will happen, but the actual countdown when the landing will happen. So yeah, that is the case.
Engine firings to place the lander into low lunar orbit, approximately 100 kilometers or 62
And I have a
miles above
surprise
the
for
lunar
you.
surface. The journey to low lunar orbit included firing the first liquid methane and liquid oxygen engine in space. This was called the commissioning maneuver. It was a full thrust main stage engine burn with a throttle down profile necessary to land on the moon. Over the last 24 hours, Odysseus has maintained its trajectory in low lunar orbit, waiting for suitable lighting conditions to begin its autonomous descent to Malapert A, the designated landing site for the IM-1 mission near the south pole of the moon.
Aiming for the South Pole. And
Our joint coverage will follow Odysseus.
yep, I have a surprise for you guys. Just look at that.
12 payloads down with it. The mission is enabled under a
Whoa.
task order with NASA's Commercial Lunar Payload Services, or CLPS.
Where did it go?
Here's more on this initiative under Artemis.
There you go.
Our moon. It seems so close in the night sky.
So what do we have in here? So first of all, let me just clarify. We have the animations for you. We have the live tracking for you. And I'm also here. So that is the case. And then obviously the live telecast. So you can right now see the live tracking. We will be able to see these. This is nothing but the Dopplers which is there. So we will be able to see if anything goes wrong, right, during the landing. The Dopplers will tell us that something has gone wrong, and we'll get to know. So this is the live tracking feed. This is the live webcast, and yes, we have live simulations for you, so don't worry about it. Everything at one place. Yep. So right now things are looking good. Everything is looking fine. We can see this. This is nothing but just animation video which I have just muted a bit. But yeah, so basically right now it's in the lunar orbit. So that countdown which you will see on their feed is actually the one which is towards the aim towards the landing. My countdown is aimed towards the countdown to start. So T-minus 1 hour 3 minutes since the initiation of the landing burn.
CLPS is an important pathway towards long-term exploration of the moon and part of NASA's Artemis missions that will establish a sustainable presence in the lunar vicinity and prepare humans for missions to Mars. For more on how this fits in with the greater plan, let's head over to NASA's Leah Cheshire, who's just down the hall. Hey, Leah.
Thanks, Gary. I'm here with Joel Kearns, NASA's Deputy Associate Administrator for Exploration. Thanks so much for being here, Joel.
Oh, thank you, Leah. It's great to be here on Landing Day, which is the culmination of about 5 years of work by Intuitive Machines Corporation.
Yeah, we're really excited.
We're getting some signals, right? You can see that. So that will happen because this in the live Dopplers. First of all, credits to MSAT for providing this feed and doing the live tracking. But yeah, so basically right now you can see a small part of this Dopplers, we can see the signal acquisition is happening, but again, this will just increase as the landing time comes closer and closer. So don't worry about it. The signal strength will increase, and I will tell you, I will commentate on how what this is all about, and if the things are looking good or not. So don't worry about it.
There's three objectives for commercial lunar payload services, or CLPS. One is that we want to do great science on the moon.
Descent orbit initiation has happened already.
Engineering for future human exploration in Artemis. And the third is we want to generate a group of companies that are highly skilled in doing these robotic lunar landings, so that we can use them as part of our Artemis initiative.
Well, let's talk about that a little bit more. How is CLPS beneficial to the Artemis campaign?
Well, a number of different ways. For example, we will do science at the South Pole with our astronauts in Artemis, and also with robotic explorers. They'll be brought down on CLPS. But we're also going to use these robotic landings, these commercial robotic landings, to do science at places where we won't initially send astronauts. We can use them, for example, this intuitive machine mission that's going on today that'll land in the South Pole region will be one of the first forays into the South Pole to actually look at the environmental conditions to a place we're going to be sending our astronauts in the future. That is, what type of dust or dirt is there? How hot or cold does it get? What's the radiation environment? These are all things you'd really like to know before you send the first human explorers. I'd also say that in the future, when we are flying humans to the moon as part of Artemis, we can use commercial services like CLPS to pre-stage equipment or other cargo, so that they're waiting for the astronaut explorers when they land.
And this is an entirely new approach that uses a privately developed lunar lander. What are some of the most important takeaways on risks but also benefits of a model like this?
So when industry came to NASA about 6 years ago and said, we could do this for you as a service, what they said was they thought it would be less expensive than if we did it ourselves, that they could do it faster than we could set up to do it, and that they could do it more frequently, that they could do more than one mission, every year or two. And so far we've seen is that looks like that's going to be true. What we're waiting to see, such as with the mission today, is can they actually do this incredibly difficult thing? Can they really land on the surface of the moon robotically? This is something which is extremely challenging and difficult to do. The moon has no air.
So, Baby Ada, we do have radio astronomers, but they don't have that, big equipment to actually follow this landing. I know people who have those equipments ready, and they can do those landings tracking. But right now, they were busy with something else, some other mission, so did not get time to configure, because a lot of configuration calibration goes into before you can actually track the lunar landing. I have been to that, the process of how it works, and also, yep.
Descent toward the lunar surface. The lander is continuing to decrease its altitude until the powered descent initiation, an 11-minute braking burn that sets NOVA-C up for the final moments prior to touchdown. That time of ignition for PDI, or powered descent initiation, is 5:11 p.m. Central Time, 6:11 p.m. Eastern. The entire landing sequence is autonomous, meaning the lander is in control of every milestone required for a lunar landing opportunity, Gary.
And completing a soft touchdown comes with challenges unique to, say, landing on the Earth or Mars, because there's no atmosphere.
Gary, it's an entirely different playbook as we've seen this dynamic situation play out today. Let's take a look at the IM-1 mission's complete trajectory approach as of launch. The Intuitive Machines IM-1 mission is sending commercial and NASA payloads to the lunar South Pole region on an uncrewed robotic NOVA-C class lunar lander called Odysseus.
The lander is the tip of the iceberg, and what's below that is the full program that is on a miniature scale, very similar to what the Apollo program had.
The IM-1 flight path mirrors the historical achievements of Apollo 2, starting with separation for the launch vehicle on a direct shot at the moon.
That trajectory is basically like throwing a fastball that is going to hit the moon 6 or 7 days later, like an outfielder stretching out to grab it.
The first 4 days are dedicated
Here
to flight
you can
controllers
actually
in Houston
see,
firing the lander's
just a
3D
second.
printed liquid methane and liquid oxygen.
So in the the live tracking, that the peak which you can see, right, that is the IM-1 lunar lander signal. So that signal acquisition has happened, and you can see the trail of it. So once the initiation will happen, we'll get to see over here and we'll get to know that yes, the PDI has happened now.
Very much the same thing.
With the B-plane on target, Odysseus is prepped for a critical autonomous maneuver on the moon's far side. This critical burn maneuver is completed in the blind, with the moon blocking direct communications back to NOVA Control in Houston.
Once we get around the moon, we have on the day side of the moon, the sun heating us from one side and reflected infrared light off the bright moon warming us on the other. Then we plunge into night, and now we're cold on both sides. It's very tough.
About an hour before landing, flight controllers command Descent Orbit Insertion, or DOI. This is a main engine firing to slow the spacecraft so its altitude drops from 100 kilometers to about 10 kilometers above the lunar surface. After DOI, Odysseus coasts for about an hour before starting its final approach.
And then we reach a point called powered descent initiation. The guidance system on board makes the decision to activate the main engine at very close to full power.
Cameras and lasers are feeding information to the lander's navigation algorithms, which provide guidance, navigation, and control. With a safe site identified, Odysseus enters a 3 meter per second descent, then down to 1 meter per second for the last 10 meters to the lunar surface. Now, the lander is using an inertial measurement unit, which is similar to a human inner ear that senses rotation and acceleration. Flight controllers expect about a 15-second delay before confirming the ultimate milestone, softly landing on the surface of the moon.
And I can tell you just from doing our simulations, that's the longest 15 seconds you'll ever experience as you wait for the final light to turn green to indicate that you've landed on the moon.
Approximately 12 minutes before our landing opportunity, we are going to show this animation of the landing sequence to describe the lander's autonomous operations, starting with powered descent initiation, or PDI. During this maneuver, Odysseus must reduce its velocity by approximately 1,800 meters per second. You can think of it as a braking phase. Then, the lander pitches upright using its main engine with the Hazard Relative Navigation, or HRN, now being fed by NASA's NDL sensors, facing toward the area where the lander intends to touch down. At this point, HRN will autonomously scan the intended landing site for a safe landing area. Then, the lander's guidance, navigation, and control system commands Odysseus to a point approximately 30 meters above the designated landing site, and the lander goes into a vertical descent followed by terminal descent. Intuitive Machines created NOVA-C for the CLPS initiative and commercial enterprise with the goal of creating a lunar economy.
And NOVA-C is Intuitive Machines' first autonomous spacecraft. NOVA stands for new, and C is the Roman numeral for 100, the lander's approximate payload capacity.
Yep.
With that, let's learn more about the NOVA-C class lunar lander.
This IM-1 mission lander is named Odysseus. The name was nominated by assembly, integration, and test engineer Mario Romero after the Odyssey and its epic voyage across the daunting, wine-dark sea. Including landing gear, Odysseus is 4.6 meters wide, and with its top-deck solar array, it's 4.3 meters in height. It's a taller design that accommodates payloads and the lunar South Pole lighting conditions. Its hull diameter is 1.6 meters, with payloads affixed to the entire exterior of the lander, making its total payload capacity approximately 130 kilograms. The lander weighs 675 kilograms, but packs on weight when loaded with fuel. Odysseus uses composite helium tanks to pressurize its liquid methane and liquid oxygen main engine that can throttle down to perform its final descent to the lunar surface in one continuous burn.
Intuitive Machines' IM-1 mission is supported by NASA's Commercial Lunar Payload Services Initiative, which allows rapid acquisition of lunar delivery services from American companies. The instruments on board advance capabilities for science, exploration, and the commercial development of the moon. Commercial companies were challenged to come up with their own way to design and fabricate a lunar lander and conduct operations. For this commercial mission, Intuitive Machines elected to support the communications between the spacecraft and NOVA Control through its own private ground-based network. And it's not the first time Intuitive Machines used this network in deep space.
Yep. Well, that's right, Gary. NASA worked with Intuitive Machines to perform technology demonstration of this capability on NASA's Artemis 1 mission, which helped us verify the network for operational use during this CLPS mission. The Lunar Data Network, or LDN, uses ground-based networks to communicate into deep space, so we could lose signal while NOVA-C is on the far side of the moon. However, the trajectory of the lander's low lunar orbit does allow for near continuous line of sight with Earth and ground station coverage. Let's head over to NASA's Leah Cheshire to learn more about this network. Leah.
So guys, right now,
Thanks so much. And
if you have any questions or something, you can definitely ask. And if you have just joined in, let me repeat what you are seeing on your screens. This is we have live animations which will start once we will the initiation, this thing. The landing starts. Then we have the live tracking also for you. We can see the peak over there, which means the acquisition of signal is over here, and we will be able to see all the Dopplers according to it, and hence we can see if something has happened during the landing, if the landing was fine or not, or all those details. So and yes, this graphic which you can see right now in front of you, here the blue line indicates the trajectory which it is going in right now. The gray line is where the moon is, the yellow line is where the sun is, and the red line is where the communication link is. So right now things are looking good. Everything is going as per the plan. It is on the coast to PDI, which is nothing but the power descent initiation. Right now we are at around T-minus 49 minutes from the power descent initiation, and T-minus 1 hour 2 minutes from the actual landing to happen. 1 hour 4 minutes to be precise. So yes, all is okay. Angel, welcome to the stream after so long. And guys, if you have just joined in, please give it a thumbs up. Give all your best wishes to the lunar lander, and we are hoping that this mission is successful. One thing which I forgot about one of the payloads was that there is one payload from I don't remember the name, but the payload is what it does is that it is actually a data center. So basically, if you, let's say, Coca-Cola recipe, right? You want to store it in a very, very secret and very, very secure location. Anything can happen on Earth, but what will happen on the moon, right? What could happen on the moon? So basically, there is a company which has sent a data center onto the moon so that you can securely, save your information up to the moon, upon the moon, basically, and nothing can access it. Nobody will be able to destroy it, basically. So yes, this is also happening. So that is something which is amazing.
And ground network console screens. It's just one of many different screens that are used by the flight controllers, and we want to bring you closer into the mission and into our Mission Operations Center. Let's take a look at what flight controller teams are seeing now. This particular screen is called the Deorbit Descent and Landing, or DDL screen. This screen is primarily used by the mission director and landing system experts. It's used primarily while NOVA-C orbits the moon and through landing. The top right images of the moon are called the lunar tactical view. When the dots turn red, the lander is on the far side of the moon, and green is on the near side. The line is the tail where NOVA-C is, with each dot representing 10 minutes of elapsed time. The acceleration sensed portion of the screen shows raw acceleration values from NOVA-C's inertial measurement unit. This is used a lot during burn maneuvers and is a more robust way of measuring acceleration over time, with the ability to look back at what has happened. For some reason, flight controllers have lost data. Finally, the column on the right is a received, accepted, edited, and failed pre-checked, or RAFE chart for short. When each of these lines are on top of each other, that's a good indication that NOVA-C's navigation system is in good health. That's because every measurement NOVA-C makes must be received, accepted, edited, or failed pre-check. The failure is a possible outlier of data that the lander's computer automatically knows is bad information. Collectively, the DDL screen is one of many data displays that flight controllers are monitoring to successfully navigate NOVA-C to the lunar surface.
Wow. Love the transparency, to be honest. Totally love the transparency.
Is an essential component for flight controllers.
You can see that over here.
Process this data for real-time decision making in NOVA Control. Now again, we're following along with the flight control teams here in NOVA Control prior to the next critical steps, including activation of the navigation Doppler LiDAR to provide guidance, navigation, and control for the landing phase. This is expected around 4:45 p.m. Central Time. The next critical milestone is powered descent initiation at 5:11 p.m. Central. This burn is the first in a sequence of maneuvers that starts about 12 minutes prior to landing, or about 50 minutes from now. NOVA-C is, of course, landing on the moon as a delivery truck for the scientific instruments and technology demonstrations on board. There are 12 total payloads, 6 of which are NASA's. Let's review a few of those payloads as we continue to descend towards the lunar surface. First is radio observations of the lunar surface photoelectron sheath, or ROLSes. ROLSes will employ 4 antennas and a low-frequency radio receiver system to determine the density and scale height of the moon's photoelectron sheath, a very thin layer of electrons above the surface of the moon, and will also detect solar radio bursts, radio emissions from Jupiter, dust impacting the surface of the moon, and how radio noisy Earth is.
An exciting radio telescope is going to be placed on the moon. It is called ROLSes.
I can
It
hear
stands
Indian.
for radio wave observations from the lunar
There
surface
you
of
go.
the photoelectron sheath. It's going to detect all kinds of radio emission that is falling on the moon. Right now it is close to solar maximum, so the sun is producing a lot of coronal mass ejections and radio emission associated with them, and we can detect these radio bursts from the sun. Characterization of the radio environment of the moon is very important. It has not been completely done, and therefore ROLSes will be able to contribute in identifying various sources of radio emission on the sun. If you're setting up an observatory on the moon, we should know what kind of radio interference we get there.
Yep, exactly.
The
Amazing.
Laser Retroreflector Array, or LRA, is a collection of 8 retroreflectors that enable precision laser ranging, which is a measurement of the distance between the orbiting or landing spacecraft to the reflector on the lander. LRA is a passive optical instrument that will function as a permanent location marker on the moon for decades to come.
Yep.
This
There you
is a
go.
little mirror that's aiming at you all the time, regardless which way you're looking at it. My name is Xiaoli Sang. I'm a LiDAR instrument scientist.
A Chinese
It's a
now?
Small retroreflectors mounted on aluminum shell on the intuitive machine landers. When you shine laser on it, and it reflects right back at you. The purpose is to have a precise fiducial marker on the landers. It serves as a landmark for future missions if you want to go back and land it there.
All right.
Stereo cameras for lunar plume surface studies, or SCALPS, will use a suite of 4 cameras to capture stereo and still image data of the dust plume created by the lander's engine from when it begins its descent to the lunar surface all the way down through engine shutoff.
SCALPS is an array of small cameras that will be placed around the base of a lunar lander and collect imagery during the descent and landing of the vehicle. Using a technique called stereophotogrammetry, we can use those images to reconstruct a 3D shape of the ground. As the lander comes down, its hot engine plumes will interact with the surface. Our cameras will begin acquiring images from before this interaction begins until after the vehicle has landed on the surface. The SCALPS cameras will specifically be looking at the overall crater formation and erosion of the ground due to the rocket plumes. The final stereo images, which will be stored on a small onboard data storage unit, will be transferred to the lander and then downlinked to Earth, where we can use them to reconstruct the overall erosion volume and shape of the ground. With the Artemis program, we plan to establish a sustained lunar exploration and try to land multiple payloads in close proximity to one another. SCALPS data will be a critical part of understanding these phenomena and improving our computational models to inform these future landings.
Radio frequency mass gauge, or RF.
David, I hope this mission is successful in that case.
Measure the amount of propellant in spacecraft tanks in a low-gravity space environment. Using sensor technology, RFMG will measure the amount or mass of cryogenic propellant in NOVA-C's fuel and oxidizer tanks, providing data that can help predict fuel usage on future missions.
I'm Greg Zimmerly, the principal investigator for the radio frequency mass gauge payload.
This is what I was talking about.
This instrument is a space-age fuel gauge. We're going to use it to measure the amount of cryogenic propellant in the Intuitive Machines NOVA-C lander propellant tanks. These propellants are very cold. They're at about minus 300 degrees Fahrenheit. Now we're integrating the instrument onto an actual lunar lander. Future lunar missions, like those in the Artemis program, will likely also use cryogenic propellants and have to store those propellants in space for long periods of time. So having an instrument like this that can measure the propellant in the tanks in low gravity will help future lunar missions know how much fuel is in the tank at all times.
Yep, this is actually what we want, right? A small description
now we'll discuss
of the
two more
payloads.
NASA payloads, navigation Doppler LiDAR, or NDL, and the Lunar Node 1, or LN1, later during our broadcast. We'll have a special guest later in the broadcast to talk NDL upon its activation during descent. And Josh, we did get word that some of the processing of the optical images from NDL are already performing. They did some checks, and they're performing very well.
Awesome.
Now, a common theme you'll find among the NASA payloads on IM-1 is helping to demonstrate technologies and our understanding of the lunar landscape that could very well improve operations for landing on the moon in the future. From understanding the environment to precision sensors to literal beacons, the technology on IM-1 will help guide technologies and operations for future lunar exploration.
And Gary, with CLPS as a springboard of innovation, Intuitive Machines designed and developed its complete lunar program to help support CLPS and carry out the essential part of that directive, which included calling for the commercial development of the moon. Back in 2018, the U.S. government declared the moon of strategic interest. At that time, few companies and institutions were working on payloads designed for the moon because no one had been to the lunar surface in over 50 years. Gary, in the time it takes to get an undergraduate degree, 6 commercial entities created payloads for the IM-1 mission. We'll view all of them as pioneers helping shape this brand new lunar economy.
And Josh, a true lunar economy should not have just NASA as a sole customer. NASA's CLPS initiative encourages a model where NASA is just one of many customers. And this is an important element to ensure that this model of transporting incredible science and technology instruments to the lunar surface is a sustainable and robust one.
Well, it's important, and Gary, it's also promising in this situation. The commercial interest for delivering science and technology demonstrations continues to grow. As of our third planned mission, we're seeing more and more non-CLPS payloads from both domestic and international companies and institutions, which are driving us towards a future, maybe completely commercial mission to the moon, possibly as soon as our 4th mission.
Well, even on IM-1, there is a variety of unique commercial payloads. It's a good snapshot of out-of-the-box ways to think about what the moon can offer.
Well, that's part of the challenge. Beyond just creating the capability to land on the moon safely, we had to look toward a new emerging ideas and find innovative ways that may add value on Earth and spaceflight. Let's learn a little bit more about those payloads and the lunar lander attempting to make history.
The NOVA-C was our version of a liquid oxygen, liquid methane lander, and we went about imagining that into existence.
Intuitive Machines' NOVA-C class 3D printed engine took its first breath of liquid methane and liquid oxygen in 2018 on an airstrip at Ellington Airport in Houston, Texas.
We didn't have enough money for a facility with blast walls and water suppression or water deluge, so we had to test outside in the environment of Houston.
Now we'll get some information about the engines.
And the humidity's like the same.
Engines information coming, guys.
18-hour day, rolling out to the runway. It was brutal. But we did it to get the critical test engine data we needed to build our own engine.
Designed, manufactured, and controlled in space by Intuitive Machines, NOVA-C's structure is primarily carbon composite.
We needed to build the lightest weight structure we could. That meant honeycomb aluminum core with composite face sheets, composite struts, and most importantly, linerless composite propellant tank. Man, what a challenge that was.
Between the engine, carbon composites, software, and electronics required to build a NOVA-C lunar lander, it took an incredible amount of touch labor to get to the launch pad.
We worked very closely with San Jacinto Community College to create a certification course for technicians, where they would take these certifications. We then, in Intuitive Machines, would give them an internship and test them out in the workplace. And anyone that showed the aptitude to be a really good technician, we hired on the spot.
Nearly all of the lunar lander's payloads are mounted to its exterior, including 6 NASA-provided payloads that will help lay the foundation for Artemis missions. Embry-Riddle Aeronautical University's EagleCam, designed to deploy off Nova-C right before landing to take third-person perspective images. The International Lunar Observatory Association's camera system, mounted at exact angles that could capture images of the Milky Way from the lunar surface. A data center technology demonstration by Lone Star Data Holdings, and Omni Heat Infinity, Columbia Sportswear's thermal reflective insulation used in many of their outdoor products, will help protect Nova-C from extreme temperatures in space.
They've got brilliant ideas, and if we can help facilitate those startups to help build this economy, I think that raises all boats, and it's as serving as the transportation leg to the moon, we're happy to accommodate those kinds of companies.
Great, great, great.
Now, the lander and our payload customers require command and control in space. Intuitive Machines' Mission Operations Center provides both of those elements. It's called NOVA Control, NOVA being the name of our lunar lander class, and Control being the nerve center of our entire lunar program. Its unique circular design fosters a collaborative environment where flight controllers and customers may make agile decisions. Let's take a live look.
Yeah, and inside that flight control room, Josh, it's important to note that these are
Look
not
at
the
their-
only teams that have been in this room over the past 7 days. This is
Look at their suits. It's literally they have replicated the USS Star Trek's USS Enterprise, right? Amazing, amazing, amazing. Who's the captain? As I remember, Wildflower said the previous stream. We don't know, but amazing. So right now you are seeing the view of the flight control center, mission control center, which is a replica of Star Trek's USS Enterprise bridge. Again, private companies, startups will always do some sort of, innovations and other things. So kudos to them, and amazing, amazing.
Out of all of these teams is on hand right now to solve these intractable problems and take the best shot at the moon we possibly can.
It really took a team to solve some of these. As you mentioned, a dynamic situation. Now, you talked about the design of this room, fostering that collaboration. It's a little different from what I'm used to over at the International Space Station Flight Control Room, where you have consoles that are facing towards large screens. What exactly is the logic behind this particular design?
Really, we wanted to get everybody together into where we're a small company. There's not a lot of us. Agility is our strong suit in this situation. And this room really suited us. It's a situation where we can put our payload customers inside the center, or let's say we need to bring in operators who have knowledge of the things that need to happen in the future that we haven't quite touched on as a team. But you can insert those folks into the center of this room, make quick decisions, respond to problems. And that's really the way that we see tackling some of the hardest challenges in the world. And certainly right now for us, this is one of the hardest challenges on the moon, most certainly.
Which we are saying absolutely, and it takes everybody in this room, and everyone has their respective roles, just like we see with any spacecraft. Each of these individuals provides insights into a specific spacecraft subsystem.
And the captain of this whole thing is usually the mission director. In this case, this is
Blue
Team.
That
is Dr. Tim Crane. He's our co-founder and chief technology officer, serving as mission director today. Now, flight control operators continue to monitor Nova-C's.
I think Wildflower, you got your answer. Who's the captain? The mission director for this mission is the captain of this bridge.
Of the moon. For more on Malapert A, let's head over to Leah Cheshire. Leah.
Thanks so much, and I am now here with Ben Bussey, Intuitive Machines Chief Scientist, to talk about Malapert A. Thank you so much for joining us, Ben.
It's great to be here.
Now tell me a little bit about this landing site. Why was it chosen? What sets it apart?
So the most important factor when selecting the landing site was to find a good, safe site for Odysseus to land. And we're landing in highland terrain near the poles, and that can be a fun challenge for the team. But we think we found a good, large, safe area free of boulders and craters. The other key factor was to try and land in the south polar region of the moon. If you know, NASA, through the Artemis program with their international partners, will be sending humans to the moon in this decade. So the goal was to find somewhere in the south polar region that was large and safe, and we sort of think just outside the rim of Malapert is sort of a Goldilocks location that will allow all the payloads to get the data that they want to get.
And you talked for just a second about that lunar highland material. That's what we believe Malapert A to be composed of. What is really interesting about the lunar highlands?
So if you look at the moon, you will see bright and dark regions, and the dark regions are lunar mare, which are old volcanic flows. The bright regions are mountains, are the highlands, which actually represent the original 4.5 billion year crust of the moon. So they're scientifically very interesting. They're also the same geology that the crew will visit. And so we want to go and get the first data of the highlands near the poles. And so we have one of our instruments, for example, is SCALPS, and NASA likes its acronym. So it's the stereo camera for lunar plume studies. And so that camera, which is 4 video cameras, will image the dust of the highland terrain right before we land. And so we will learn how it behaves as landers come down. So as we start to put multiple things near the poles, we know how far away we have to land.
And we know that there are some interesting conditions for these areas in the lunar South Pole. That can be lighting, that can be communications, terrain itself. So what can we expect at Malapert A?
So yeah, as you get very close to the poles, the lighting and communications becomes very challenging. And so for IM-1, we've gone to about 10 degrees, about 300 kilometers from the pole. And we think that's a good location because it's the closest to the pole that anyone's landed. But for example, we've chosen a site where you can see the Earth all the time, which is one of, obviously, communications being a key challenge. Whereas for IM-2,
talking
our second
about
mission later this year,
I totally forgot. So the mission duration for this mission, IM-1 mission, is going to be 7 days. It's not going to be 2 weeks. It's going to be 7 days. So it will die after 7 days, which means it will after 7 days the lunar night will happen and it will not be able to survive that. So we'll have to see. I hope first of all it lands, and maybe, just maybe, it survives after lunar night. We don't know.
Thanks, Leah. Yeah, Malapert A is a fascinating satellite crater to Malapert, a crater only 300 kilometers from the moon's south pole. The site is named after Charles Malapert, a 17th century Belgium astronomer. The area around the landing site is believed to be made of lunar highland material, similar to Apollo 16's landing site. Apollo 16 was the first Apollo mission to visit the lunar highlands in an area called Descartes. Scientists believe the highlands offered insights into the moon's early history.
People say lunar landing was fake. Look at all this. Look at all this.
A sample of rock called a northocite was recovered from Descartes, which solidified more than 4 billion years ago during the moon's formation, when the outer regions were still molten. The IM-1 mission is carrying NASA payloads that may help better characterize this important scientific landing site for future Artemis missions.
And Gary, we were originally targeting from NASA Oceanus Procellarum. It was a lunar mare in the region of the near side of the moon. The decision to move from the original landing site in Oceanus Procellarum was based on the need to learn more about terrain communications near the lunar South Pole, which is expected to be made up of some of the best locations for sustained human presence on the moon. Landing near Malapert A also will help mission planners understand how to communicate and send data back to Earth from a location that is low on the lunar horizon.
Now we're coming up on the NDL activation. We have more information about how Intuitive Machines flight controllers intend to land on the moon using this NDL, NASA's Navigation Doppler LiDAR.
Gary, since choosing to orbit the moon one more time, flight controllers have been working to resolve a challenge with the lander's laser rangefinders assigned to the terrain relative navigation and hazard relative navigation cameras. Those provide landing solutions to Odysseus. The lasers are intended to determine altitude and horizontal velocity, but the ones on the lander right now are not working.
These are essential measurements required to land on the moon. And while NOVA-C's laser rangefinders are not operable, NASA's navigation Doppler LiDAR sensors are.
So during the last 2-hour orbit, flight controllers have been loading software patches and resetting the lander's guidance, navigation, and control system to use 2 laser beams from NASA's navigation Doppler LiDAR as primary navigation sensors to land Odysseus.
That's right. And we're coming up on the timeline for when NOVA-C is about to begin the activation of NDL. This is a 3-step process from powering on, becoming ready for operation about 5 minutes later.
They had a redundancy, guys.
And hazard relative navigation cameras ahead of NOVA-C landing. So while we wait, let's learn a little more about NDL.
So the Artemis program is taking
Okay, let's listen in first of all.
And everything that goes there, including the instruments and people, must be flown there safely and landed there precisely. So the landing phase of that task is one of the most critical aspects of it. NDL is a LiDAR instrument that is used to enable that capability. It uses light in the same way that sonar uses sound. For NDL, we have 3 telescopes where light would come out of the telescope, hit the moon's surface, and some of that light will be reflected back. These telescopes are mounted on the outside of a vehicle so you get a clear view of the ground as it's coming in for a landing. In the Apollo era, large radars or astronauts using their eyes looking out of a viewport were used to help land the vehicles. NDL is going to have to take the burden off of the crew with a much smaller, lower power, and more accurate instrument.
And we just got an update from one of the flight controllers that the HRN and TRN cameras assigned to NOVA-C are still nominally processing images using 2 of those NDL lasers. Quite the feat, Gary.
No, it's absolutely incredible and a very important milestone to reach. Now, with that understanding, let's learn more about how this technology is playing an active role in this dynamic situation. Let's head over to Leah Cheshire. Leah?
Thanks so much, Gary. I'm joined now by Prasanth Desai. He's NASA's Deputy Associate Administrator for the Space Technology Mission Directorate. Thank you so much for being here.
Bro, that was not expected. Okay, let's just listen in the technology on landing.
Doppler LiDAR. And one of the challenges for doing any space missions is knowing where you are and trying to figure it out, right? And so we're looking to develop newer capabilities that we can do that more precisely and that take up less volume and mass on the spacecraft so that you can have all the available payload mass for instruments and other scientific things we're trying to do. And so this is the next generation of a new capability where we're trying to go from the traditional measurement using radar to a laser-based system. And so that's what this navigation Doppler LiDAR will be doing, is sending out 3 laser beams to try to get the velocity measurements in the lateral direction as well as the vertical direction.
So when it comes to NDL, what are some of the challenges we expect to see when using this technology?
So we've tested it on the ground in a number of platforms, from helicopters to landers here on the surface, on the Earth, to test this out. But this is the first time we're going to test it actually in the space environment on a lunar surface, right? And so we will see how that different environment will really affect the systems, right? And so one of the things that we would really like to know is what how the pulse comes back after they send the laser, and how it reflects back to the system, how long it takes to process, and how it will help define the solution to figure out the trajectory to go down to landing on the surface.
Now, this technology has become a little more critical for today's mission, so can you talk about how NDL is now being used in today's landing?
Right, so we put this as a tech demo with tech demonstration as a test. Right? We weren't planning to use it in line with the actual mission coming down to the landing, but now we are. So basically it is now the primary system to help provide the velocity and altitude information so that the lander can land safely on the surface. And that's important because as the lander comes close down, we don't want it to tip over. And so we need to get an understanding of the vertical velocity so it knows how much thrust to slow down, but also the lateral velocity, because if it comes down sideways too much, it can tip over and fall. So by knowing the velocity, the lander can decide exactly how to come down and hover, basically slowly to come down, and that's why it's really important to do this testing. But here we are today. We're going to try it for the first time in line, and so we're very excited for the mission.
Yeah, a demonstration totally in action.
Yes.
So just very briefly, there are 2 other tech demos on this mission. Can you cover those very quickly?
Yeah, so 2 other things that we're trying to improve on is one, radio frequency mass gauge, which is to try to get a measurement of the fuel that's on any system, any spacecraft. One of the things about low gravity is the propellant doesn't settle down, where like in a car gas tank, it's on the bottom so you can measure it easy. In space, it floats. And so how can we do that so we know how much propellant there really is? And then the other one is scalps. One of the things that as it lands, the thrust is going to throw up all this eject of the lunar regolith and thing. And so we have 4 stereo cameras that are going to take images of that and get data so that we can improve our modeling, so that in future landings we can make them more safer and things like that. So we're using that as a technology demonstration as well to improve future landings to make them more safer.
Well, thank you so much, Prasanth. It's really been great speaking with you, really exciting stuff. And for now, we're going to send it back to Gary and Josh.
All right. So that was the update, guys. So basically, to summarize, we are the NASA's, the Odysseus laser range finder is not working, which is what it was supposed to do utilize for landing. But instead, it will be using the NASA's NDL now, which was supposed to be a tech demo, but it is now mission critical. Okay, so that will also function like that only. So it will give 2 laser ranges and laser beams basically, and then it will be reflected back, and then accordingly it will use the data. It is already working right now in HRN and TRN, which is nothing but terrain relative navigations, which is what they took when the images which they took when they were in the orbit. So it's working, it's looking good. So hopefully the NDL is able to land that spacecraft on the lunar surface. We are right now T-minus 19 minutes from the landing to start. Everything is looking good, and although there was a hiccup during the landing because of this, but I think that is not really a hiccup, and everything will work fine, and we will get to see the landing today. Also, we should note that there will be a Eagle cam, which is the camera which will be deployed at 30 meters from the surface, which will take a third-person POV of the landing. Then we have a stereo cams which are placed near the landing legs of the spacecraft, which will take the images of the landing and how the lunar regolith and plume interacts with each other. So amazing, and I'm hoping that it actually lands on the lunar south pole. And I'm hoping that my lucky sweatshirt is going to do that, because this is what I wore during the Chandrayaan 3 landing, and it landed. So hopefully this is the case and we get to see the landing today. Right now on the screen you can see the live simulations which will start once the landing starts. The live tracking is already there. We are getting a loss of signal although over there, but it will hopefully we'll be able to get the proper Dopplers coming in, and hence we can analyze when the landing has started, if landing has gone wrong, or if it has properly landed or not. So hopefully everything is going to happen in next 30 minutes or so, with the action starting in T-minus 18 minutes from now. So just stay there, relax, and let's hope for the best, and just give your best wishes, give it a thumbs up, and let's hope this is a success for today.
Very economical proposition. It's a risk posture which is more risk tolerant than NASA is accustomed to. There's not a single one of these companies that's willing to bet their mission on a coin toss. Every one of them is doing what they can in order to have the most successful mission possible. But the important thing to realize is that risk tolerant does not mean risky. And the rewards are a long-term ability to get payloads to the moon inexpensively, frequently, and rapidly.
We want science, so we can then put more of our resources on even more science, exploration, and technology payloads and get more of a return on investment when we get to the moon.
CLPS provides tremendous benefit across the scientific and economic communities.
So there's a lot we'd like to learn about the moon to help human habitation and prepare us for missions to Mars and beyond.
So the moon is the first step.
The teams here in Nova Control have been working diligently over the past 7 days to take us this far and are laser focused on the operations ahead. We're following the clock down to the start of those autonomous operations of NOVA-C, starting with the powered descent initiation. For now, we're heading back over to Leah Cheshire, who's standing by with NASA's Associate Administrator. Leah.
Thank you, Gary. I'm joined now by
all right. It's happening,
NASA's
guys. T-minus 16 minutes from the landing to begin. Although we are seeing the signal is becoming weak, but we don't have to worry about it because this thing can happen because of the altitude. Since it is approaching the altitude is becoming less, and that is the reason why the pointing because of the altitude as well as the angle which it is pointing towards the Earth, this thing can happen, but hopefully this will remain strong for us to observe the trackers, the Dopplers, and let's see.
We talked a little bit about how this is a different model for us. So how does NASA help ensure success while we also allow these companies to figure out their solutions?
We're able to offer our technical expertise, so companies can ask for technical experts from NASA that might be an expert on lunar surface conditions or orbits around the moon, or even just in assembly of the spacecraft, the vehicles. But they can also ask for help during the mission. We provide
you can see the distance from the moon,
to get the
26 kilometers. And it will
the control center here.
Right now you can see 25 kilometers. It's decreasing, and at around 10 kilometers is also is the periloon, which means the lowest point of the orbit. So we have to see how it will work, but yeah.
So what are some other ways, and why is NASA pursuing this commercial route?
Again, if you are just joining in, guys, we are T-minus 14 minutes from the landing to begin. Everything is looking great. So Steppenwolf, that timer which NASA has right now is of the landing time. My timer is of when the landing is supposed to begin. So there's that difference.
That allows us to get our resources and use them elsewhere to do other parts of our mission, exploring the moon or beyond.
You talked a little bit about Artemis for a second. So how does CLPS fold into NASA's plans with Artemis and with this Moon to Mars architecture?
I think I could talk about Artemis for hours. But CLPS is absolutely essential for Artemis. It's our first steps of understanding the lunar environment. So the Intuitive Machines lander is going to help us understand how the lunar dust moves as the rocket
it will not Mars 2028.
The rocket hits that dust.
I mean, anything can happen, but the designated landing site is around 300 kilometers away from Chandrayaan 3. So, but yeah, anything can happen. Doge to the moon, Pete says. Yes, yep. That will happen with Starship. So, but yeah, Doge to the moon. Right now, NOVA-C to the moon, and NOVA-C is going to start its landing in 30 minutes from now. I am so excited. Everything is looking great, and hope.
From the flight control teams shared that NOVA-C is less than 30 kilometers above the lunar surface and is in the lunar southern hemisphere. We're still on track for PDI at 5:11 p.m. Central Time. NOVA-C will perform this maneuver to slow the vehicle's descent, then pitch over and scan the landing site for hazards, making any necessary corrections in the final burns to ensure a safe landing. We've highlighted 5 of the 6 NASA payloads so far throughout our broadcast today. Let's talk about the final NASA payload, LN-1. Lunar Node 1, or LN-1, is a small CubeSat-sized flight hardware experiment that integrates navigation and communication functionality for autonomous navigation to support future lunar surface and orbital operations.
Lunar Node 1 is meant to be a demonstration of how we can use various navigation technologies to figure out where you are in and around the moon. I'm holding in my hands the Lunar Node 1 mass simulator. We use this build to test out our vibrational modes, put on a shake table, and also do fit checks with the lander itself. Inside of our payload, we have multiple electronics boards that fit within this chassis that is a little bit about a half a U in size.
Also guys, if you want to learn more about this mission and what it is all about, I've already covered each and everything in so much detail. You can just after this stream ends or right now also, you can just go back, rewind the stream, and you can see all the things which we have discussed, which is related to today's landing. And yep, we are T-minus 11 minutes. Everything is looking great. The signal is also kind of improving, so yes, let's hope.
Concept of operations with the implementation of MAPS, or the Multi-Spacecraft Autonomous Positioning System. Ideally, this kind of technology can support a network of communication and navigation amongst local surface and orbital operations. LN-1 will test multiple navigation links from the surface of the moon back to Earth to characterize both MAPS transfers as well as GPS-like signals that could support a future lunar communication and navigation network.
Gary, one of the best things about communication and data is getting imagery back. And Intuitive Machines has several camera systems on board, including EagleCam. It started as a challenge from our CEO, Steve Altimus, to his alma mater, Embry-Riddle Aeronautical University. Students and faculty created EagleCam to take an out-of-this-world selfie of Odysseus landing on the moon. The camera system could capture the world's first ever third-person picture of a spacecraft making an extraterrestrial landing. The camera system is designed to deploy off of NOVA-C approximately 30 meters above the lunar surface and take images of Odysseus during landing. Additionally, the device will test a dust removal system, which could lead to the future advances in spacesuit technology. As part of this project for EagleCam, Embry-Riddle teamed up with NASA's Kennedy Space Center to demonstrate the NASA-developed electrodynamic dust shield, or EDS. EDS uses an electric field to remove dust. The technology was tested aboard the International Space Station and will be the first ever demonstration of EDS technology on the lunar surface after landing. Intuitive Machines also had several cameras on the lander, including wide and narrow field of view cameras. They started the mission with incredible imagery as the SpaceX second stage deployed our NOVA-C Lunar lander, capturing iconic images of the Earth after separation. It requires a lot of planning, work, and just a hint of luck. Payload integration managers programmed the lander's wide and narrow field view cameras to take 5 quick images every 5 minutes for 2 hours, starting 100 seconds after separating from SpaceX's second stage. Out of all of those images that were taken, we ended up with just 4 inspiring ones to show humanity's place in the universe. And right now, we're a little more than 10 minutes from powered descent initiation. Let's go to Leah Cheshire one last time for the final interview ahead of this critical maneuver. Leah.
Thanks, Josh. I'm here now with Nikki Fox, NASA's Associate Administrator for the Science Mission Directorate. Thanks so much for joining us.
Thanks for having me. This is a great day.
It is a great day, and you're watching this with leaders from NASA and Intuitive Machines, just very close to here. What's happening in the room right now just before these final descent maneuvers?
Oh, there's just excitement, anticipation. Everybody knows landing on the moon, going to the moon is hard. And we're already celebrating because this mission is already a success. We've launched, we had a beautiful launch. We've taken great science data all the way, every single challenge. The team has really risen up and solved it. And now we're in lunar orbit, minutes away from starting our descent down to the lunar surface. So for me, so many successes with this mission already. So just a lot of excitement.
I'm loving that. So we are working with these American companies in a very unique way. These are challenging goals, and some people would probably consider this a bold endeavor. But what does it mean to you when you look at pursuing challenges in a bold new way?
I mean, you're right. It is bold. It is a new way of doing science. It is a partnership with totally new companies who haven't done these things before, and we are partnering with them, and they are taking our science. It's a way for us to get more science and more technology to the moon quickly. So it's faster. It's very cost-effective. It's very efficient.
We have lost
we're
the
on our
signal
way.
on the live tracking, but that could be just they have switched the antennas somehow. So we'll see. Don't worry about that right now. The lander is in perfect health and it's working. So T minus 7 minutes from now, and it will start to land.
In very profound ways. So super excited.
You said high reward. So I want to talk for a minute about the valuable scientific insight that we can get from the moon. What is that? What does it mean for NASA?
I mean, there's so much we can do on the moon, particularly where this one is going down to the South Pole. We think we're going to find great volatiles down there. So as we get prepared to send our astronauts there, then we know that there's water there and we can use that water. Water's very heavy to carry, so it's really great if you can use it on the moon. We can break it up into hydrogen and oxygen, use it for fuel. Really great for our sustainability, but also where they're going is one of the oldest regions of the moon, about 3.85 billion years old. So we can actually learn about what our solar system was like before life started. Life is very noisy. We're very, very noisy here on Earth. The moon is just like pristine, and so we can really do some amazing science.
I look forward to learning more about it. So any final words before we wrap it up?
Just thank you. I mean, literally thank you. This is
T minus 6 minutes from the landing to begin. Everything is looking great. Although we have lost the signal because something they might have changed the thing, or the antennas. But yeah, they will try to get the signal. So don't worry about it. But yeah, in reality, everything is working fine. We are approaching the landing time, T minus 5 minutes from now, and hopefully, today, after 52 long years, America will be on the moon. I hope that happens.
Here that there was a maneuver to burn attitude, which means the lander is starting to make the positional requirements needed. And we're going to start listening into the IM-1 channel so folks at home can hear. We just heard from flight controller about 5 minutes until TIG.
Altitude of 10 kilometers, downrange 1,100 kilometers.
TIG being time of ignition, so we're inside of 5 minutes.
TIG minus 5 minute deadpans.
TIG minus 5 minutes. We are standing by for powered descent initiation. Gary, this is a critical 11-minute burn to slow the lateral velocity such that NOVA-C can pitch over for further operations.
Okay, it's happening, guys. T minus 4 minutes from the
main engine gimbal checkout was completed.
To happen.
So now we're focused on the operations with NOVA Control. For folks at home, we are listening into the live channel there.
That's right. A lot's happening in NOVA Control. We're going to be hearing these status calls periodically as we follow the flight control teams that are monitoring NOVA-C's descent towards the lunar surface. A lot's happening, Josh. Of course, we have this 11-minute burn. We're focused on the propulsion elements of this PDI. At the same time, the spacecraft is oriented in such a way that it can use a technology called terrain relative navigation to scan the environment along the way. What's happening there?
Right, so we know that we needed terrain relative navigation then when we were descending and coming down to the lunar surface. Now, this involves two pieces. You have a camera and you also have a laser rangefinder. At the top of the show, we started talking about, hey, the laser rangefinder that Intuitive Machines put on NOVA-C, it's not operating. We made the decision for flight controllers to utilize 2 of the laser beams from NASA's NDL payload, make the software patches required to reassign those lasers into the TRN and HRN cameras in order to give us an opportunity to land on the south pole of the moon today. Gary, is quite the feat.
T minus 3 minutes from the initiation of the burn, guys. This is happening. America is going to the moon, and after 52 long years,
It
Oh
appears to
my
be
God.
paying out. The last
Let's
call-outs
see.
that we heard,
I
Gary,
think
we're
okay,
talking about
this is
getting,
looking good.
beginning
I hope
processing
we'll get to
optical
see
images,
the
and that
landing
was nominal. The last
tracking
time we
also,
heard
and
that was just about 20 minutes
just
ago.
see.
The
Let's
status
see.
checkouts of these critical systems are essential to understanding the performance. The folks you see now on your view, this is Nova Control.
It's
They're
approaching.
monitoring
The
every step
initiation
and
is
all the data coming
ignition
from
is approaching,
NOVA-C
guys.
ahead of PDI, which is scheduled just a little bit after 5:11 p.m. Central Time. Exactly what are these folks looking at, Josh?
Well, right now everyone's looking at their assigned screens, and all of them are tailor-made. Generally, there's a few who are looking at the same type of screen, but they're tailor-made for their task. You have Spark looking at electronics, things like how hot are the electronics. Payloads are monitoring different parts and pieces.
5 degrees to burn attitude.
5 degrees left until burn attitude. The vehicle is still getting ready for this PDI ignition, which we expect here in just about 2 minutes, Gary. Two minutes. So everyone's looking at their
Hey,
screens
thank you
and
so
doing
much
their respective
for
jobs
that,
and reporting up into the mission director. While the
1999.
activity director is keeping in touch with everybody and making sure we're putting.
Excellent video. Congrats on Chandrayaan 3 from US Space and Rocket Center, Alabama. Oh, thank you so much, Joe, for that 1999. Really appreciate it. And yes, I am wearing the Chandrayaan 3 sweatshirt only, guy. That lucky sweatshirt. So hopefully today is the day when America is returning back to the moon.
1,800 meters per second, and that's required to get this lunar landing opportunity in just a few minutes.
90 seconds to take.
Propellant tanks at flight pressure.
All right, 90 seconds until we begin that propulsive maneuver. Again, power descent initiation is about a 10 or 11-minute burn that will slow the spacecraft's descent. A lot's going to happen after that 10 minutes, Josh. This is a single continuous burn. After that, we're going to see a lot of events in rapid succession: pitch over, vertical, and terminal descent.
And we just heard another call out from the prop console saying that feed line prep is complete. What that means is NOVA-C's propulsion system, that mixture of liquid methane and liquid oxygen, that feed line is prepped, getting ready to go into an injector to blend those two propellants, and the propellant and the oxidizer, and have ignition of PDI.
T-minus 45 seconds remaining, guys.
A minute, Gary.
Before it happens, everything is looking great. Don't worry.
Burn attitude.
Power is gone from
Lander
his
is
side.
getting into the correct attitude required.
Feed line prep complete both sides.
Another call for feed line prep complete for liquid methane and liquid oxygen in preparation for this PDI burn.
It's happening, guys. It's happening. T-minus 20 seconds remaining. Everything is looking great.
15 seconds, exec mode.
15 seconds to exec mode. We're tracking a little less than a minute, though, until the time of ignition for power descent initiation.
Settling. Ignition.
And we have ignition. This is happening, guys.
There we heard main stage ignition. That's coming from our prop console, Rob
Good
Moorhead.
control.
GNC call on good control.
Thrust to weight 1.5.
These are great call outs in between our prop console and our flight manager, Scott Tamblin, calling it as the data is feeding into the lander, which means we are continuing to have good communications. The lander is sending that back to flight controllers in Nova Control. Gary, something we prepared for, we planned on, is that loss of communications. And that's why we have this.
I see good thrust control.
It's a good thrust control call from prop, but that's why we have this autonomous lunar lander. You know, we program, we know that, hey, we want to light PDI in this moment. These are the steps you need to get there. But from here in, this is an autonomous lunar lander, and flight controllers are monitoring communications and tracking the progress right along with the public right now with us.
NOVA-C has the helm. It is in control and is making the decisions necessary to ensure a soft landing. We heard call-outs about thrust, full thrust right now. There is the ability to throttle that thrust, and we'll see that throughout the descent as the fuel tanks continue to unload and we expel that propellant.
And we did have a few questions come in about how much gas are we giving this to slow down the vehicle. And we want to remind folks that this PDI burn goes
Commanded thrust 90%.
Goes in just about 90%, right on time. So it goes in at 90% in order to, if the lander makes a decision and says, I need to slow down more and make a decision to make a safe landing, a little bit more oomph and make that decision a reality rather than just a possibility.
Just a second. Yep.
Fido, I'm showing 500 kilometers to target, but my display's a little bit stale.
That's the mission director, Tim Crane, calling about 500 kilometers, but stating that his information might be just a bit stale.
1,000 PSI in the helium tank.
It's part of the reason we're showing this animation, Josh. Of course, this is not telemetry driven. We're just showing you exactly what's happening. As we hear the calls, this information is relayed through the audio loops. Not enough bandwidth to do a live stream of this, so we're relying on the data that's being fed from NOVA-C to NOVA Control.
Yeah, that data is going into the flight controllers, and what you're seeing on your screen right
now.
So,
guys, it's
happening. Just to give you an idea.
Right now, the landing is going on. T plus 2 minutes 40 seconds in flight. We are right now T minus 10 minutes from the touchdown. Dopplers are we are not getting a signals in the Dopplers. That's why it's not we are not getting it. But everything else is looking fine. We are looking at that the T plus 3 minutes from the landing. You can see in the animations also, in the simulations also. And I'm really excited. This is happening. Sorry for the hiccup. The power went down, but yeah, you were able to see everything.
This is where we start getting a little tricky as far as there is a final approach. It may add a few seconds. It may add a little bit of time, but we are intended to land right around 17:24. That's 5:24 p.m. Central Time. But know that there is some give and take. We're also expecting, plan for, and train for a little bit of loss of communication during this process.
That's right. And that communication is absolutely important. And part of the reason, and we've been stressing this, Josh, is the autonomous operations of NOVA-C. Part of that is after it performs that pitch over maneuver.
400 seconds to go and breaking 1. Good control.
Fido, I see TRN depause processing. In flight.
All right, that was the call that we were waiting for. That was our major problem we've been working on in this dynamic situation, is getting those images processed from the HRN camera, TRN camera, which in this case, a dynamic situation, we had to improvise a little bit and reach into those 2 laser beams from NDL, figure out a patch while we were in lunar orbit, just about 2 hours, and it sounds like we are getting good readings from those images.
It's
absolutely
going on, guys. Although I would have loved the actual telemetry, but yeah, we are right now. You can see 1800 meters per second velocity decrease has to happen. I hope we are able to see all those datas, because that would actually give us the information. But yeah.
Decisions and scan the landing site underneath it and make decisions in an area that calculates the terrain to make sure that it's landing in a safe landing zone.
Right, so we finish up PDI, pitch over, and we have to use that hazard relative navigation, a critical tool in order to land on the moon. To make
in the Dopplers also, we can see that we are getting a very faint signal, but we can see that it is changing because the velocity has obviously velocity is continuously decreasing. So we are getting some signal. It's very faint, but yeah, we can see that Dopplers over there.
5:16 p.m. We expect PDI to go until about 5:21, 5:22.
300 seconds and breaking 1.
Everything is looking good right now.
To approximate those
I am so excited, man. This is happening. It's going on the south pole of the moon. Remember that. That is very, very challenging. And we all know what happened to Chandrayaan 2 when they attempted their first south pole landing. I hope that does not happen today. Everything works as per the plan.
First weight is 1.7.
Following along, after those critical maneuvers,
committed thrust still 90%.
90% thrust. We'll hear those call-outs periodically. We started at full thrust, 90%, still throttling. And
6 minutes left until the landing happens.
That's a great call out. 2 things there. Nominal performance on this engine as well as the helium tank. So what we haven't mentioned so far in the show is that the helium tank pressurizes that liquid methane and liquid oxygen tank. But in addition, it's also used for reaction control system. Those are the small spurts that you see at the top of the lander in the animation that control the vehicle's attitude. So for things like landing on the moon, you really want to land at the right attitude. That way your antennas are facing back direct line of sight to Earth, and you can get that ultimate confirmation once you do suspect that you have landed on the moon.
The antenna alignment is an important element of landing on the moon, Josh. We're expecting the high-gain antennas to be pointed towards Earth to confirm, but there may be a delay.
We are expecting some sort of delay. I had talking to the mission directors about how quickly we could receive a positive confirmation after this landing process is through, and there was some dispute over how long. The earliest was just about 15 seconds after we see timing of when the event is supposed to happen. So right now we're tracking about 5:24 p.m. Central Standard Time. So maybe anywhere from 15 seconds after that, maybe a few minutes, 2 to 3 minutes while we work to acquire that signal. Because as you mentioned, the lander is going to a general area.
9 kilometers altitude.
Yes,
9
Jeff.
kilometers altitude call from Tim
You
Crane.
can see
the lander's
thanks for the compliment though, but coming back to the topic, yes, the Dopplers, you can see it's changing. There is a very faint line in the Dopplers, a very small line which is visible, and that is actually the changing. It's changing, that it's not straight, it's changing because the velocity is decreasing over there. It's in the power descent. What we need to say is that the decrease in velocity is constant. There is no as such uneven distribution. If there is any uneven distribution in that waterfall, that means there is some issue with the landing. But right now everything is looking great. So T plus 8 minutes 22 seconds into the landing, 4 minutes more remaining. We'll see whether it is landing successfully or not. Everyone is hooked up to the screens and see how will that happen.
Next series of maneuvers to get us towards vertical and terminal descent. It starts with the pitchover.
And just looking at our notes here, we did go into this burn expecting pitchover at 5:21 and 57 seconds. So good call out on the timing of that maneuver. It's important to remember PDI starts an engine burn that does not stop until landing. So this is a throttleable liquid methane, liquid oxygen engine. We lit the engine at PDI, and while we are changing into a pitchover, vertical descent, and terminal descent,
3 minutes remaining.
Landing, that is a throttle down to the lunar surface. And when we do get out of PDI, if we hear that call of PDI complete, good burn, everything after that is going to happen in very quick succession, Gary. The time it takes to go from pitchover to landing, or what we estimate landing to be, just looking at maybe 90 seconds is what we expect nominally.
3 minutes to touchdown.
There is some wiggle room. 3 minutes to touchdown call from the mission director.
Okay, this is happening, guys. This is happening.
For an on-time landing that sets us a little after 5:23 p.m. Central Time.
Right, our notes going into this burn, 5:23 and 25 seconds.
In the Dopplers, we are getting constant data
Josh
only.
Sets this to a clock. This is exactly what we got relayed before the start of our
Still
coverage
processing.
today. We're right on track.
DPAS, terrain relative navigation measurements.
Excellent call out. That solution that flight controllers were working so hard
T
on.
plus 2 minutes, T minus 2 minutes and counting.
Pulling on extra resources that weren't originally planned from those 2 laser beams.
Right
from
now,
NDL.
the pitchover maneuver has happened in reality. So it will try to do the hazard avoidance maneuver, which you can see in the animations also.
It wasn't a situation where we could just sit in lunar orbit and try to solve our problems indefinitely, and it's sounding good so far on the call.
2 minutes remaining till touchdown.
2 minutes to touchdown. That required a patch to be designed on the ground and uplinked to NOVA-C.
Hazard avoidance is going on, guys.
Those laser sensors on NASA's
hazard avoidance is going on. Everything is looking great. 2 minutes from touchdown.
Navigation. That call out is fantastic.
Fighter, do you have an altitude reading?
Now is the problematic situation which occurs. Crossing my fingers. Totally crossing my fingers.
Standing by to see if we can get an altitude reading from Fido here. That's Flight Dynamics Officer Sean Stewart on Blue Team.
Please give us the altitude reading. Not looking good.
Confirm that looked like a pitch over gimbal.
This is happening. It's happening. Okay.
Like we have
okay.
some data that confirms pitch over. This starts the HDA process. That's hazard detection. Of
1 minute remaining, guys.
Heard Gary and I talking about the problem that was attempted to be solved in lunar orbit, making the decision to not only postpone this show.
NDL indicates altitude of 1,000 meters.
1,000 meters above the surface.
Meters call out from NDL,
And we have landed on the animations, but wait. Reality.
Right now, NDL was not intended to be the primary landing system on this. Instead, we're using 2 laser beams from NDL and feeding that into that hazard detection and avoidance system that you see on your screen right now, with the lander making autonomous decisions about where it wants to land. That's
30 meters.
1 minute remaining to touchdown.
1 minute.
1 minute remaining for touchdown.
Okay.
And again, that's the time of touchdown. It may take some time to actually confirm the status of the lander.
And in this process, we do have a deployment of Eagle Cam attempting to take the third-person images of NOVA-C going down to the lunar surface. We are inside of 1 minute, Gary.
Okay, guys. Oh my God. Will it land or not? 1 minute. 1 minute. Until the landing. Dopplers have gone. Not a good sign.
And we're tracking here in the broadcast booth. The clock has reached the expected.
May take a minute for comms to reestablish standby.
There it is, mission director beating us to it. We've reached the expected time of landing, but now is the process of waiting for comms, and we are in standby mode, as you heard it from the mission director, Dr. Tim Crane.
Has it landed? We are in standby mode. We need to see. Okay, man. This is the actual suspense. It has landed on Kerbal. Oh my God. We have lost the signal.
1 minute has elapsed from the notes that we have, Gary.
We have lost the signal on the live tracking, guys.
Carrier lock.
That's MD asking if we are getting the ground stations locked on to NOVA-C.
Oh my God.
That carrier lock call, Gary, we expect that to come from GroundNet or COM, that conversation possibly not happening on our public channel that we have access to. We're just standing by to hear that come through the channels as we approach almost 2 minutes since we estimated the landing time. We did get a few call outs on the side, folks coming into the room saying there was about a 2-minute forgiveness in our timetables.
We are checking our antenna reception.
Checking antenna reception.
Not good, looking good right now. Getting Chandrayaan to flashbacks, but seal my face, seal my mouth for that. Please give us some data. Please, NOVA-C, talk back.
And we're standing by, Gary. We're standing by just as we approach 5:26 p.m. Central Standard Time. Given those mission directors' notes of the flexibility between what we were tracking, what we were given was just about 5:24.
All stations, this is MD. Please look back through your logs and confirm the last information you had, and we'll determine if this is a comm outage.
Oh my God.
And that's the mission director, Gary. These are our notes here of what we believed. We talked about the comm outages with the lander making autonomous decisions. This is the process of going through the last bit of data that came into NOVA Control and working to verify, okay, this is the last bit of data. Where was the lander possibly going? How do we look for it and establish those communications?
We did not
NOVA-C
get the
uses
telemetry,
4
man.
antennas placed at the top of the lander that are designed to capture these communications, but we did expect this. We talked about it, that this is a communications challenge in it of itself, and right now we're standing by to hear that communications call out.
Still
Just a little
transmitting.
more than 3 minutes from the time of when the clock reached 0 for
Oh my
NOVA-C
God.
landing on the moon.
Okay. No happy people. Yes, that does not look good. Although, like amateur radio astronomers, radio observers are saying they are still receiving some sort of signal. Not sure. We need to see everything from here. Is that possible or not? because the communication blackout, as he said, time to forgiveness was 2 minutes.
And we just checked with our team here in the broadcast booth, decided to let's stay on this. All the chatter we are not hearing on this public channel, Gary, all things indicate that we are working to solve a possible communications challenge in this moment. So we're going to continue to stand by.
Bro.
For those following along.
MD Prime on IM-1. Go for Prime. Yeah, I guess you polled the room looking for states, and we're going to go ahead and cycle the ground transmitter on Goonhilly and do some RF sweeps. Is that your plan?
That's correct.
Roger, copy.
And that's just what we had in mind in our notes, Gary, is that if we encounter a communications challenge, we mentioned how difficult it is to land on the moon and continually have those communications. What you just heard there is folks talking about using the Goonhilly Earth Station Limited dish in the UK.
That is
to do
the
a
most
sweep
important one
looking
right now.
for that signal. We mentioned that autonomous process of...
That Goonhilly station is actually the critical one right now because it has the direct line of sight towards the moon right now, and it has a good antenna, so anything related to any faint signal or something, it will be able to pick that up. It will do the sweep, basically try to capture as much possible information as possible, but people are not looking good. I am getting Chandrayaan 2 flashbacks, you know, those anxiety, all those things.
We're going to confirm our pointing vector with our antenna for post-landing.
Yep. We spent about 2 hours in orbit to solve that problem. We got good readings on the way down. And right now, we are working to confirm communications on the surface of the moon, roughly around the Malapert A region. That is the South Pole region of the moon.
That's right. What we do know is the power descent initiation. We were following along in the status calls. We executed a pitch-over maneuver, and we're counting down the clock.
Actually, I can see right now the people in who are you know, seeing those amateur radio observers. They can hear a signal, but a very, very weak signal. So let's hope that we will be able to get the signal down. Very faint signal is coming. That's what they say. But again, we need to resort to official sources.
Yeah, I'm looking at our phase plane there for the last part of the flight. Looks like we had excellent pitch and yaw control throughout, but I did see a little bit of a roll excursion. Could it be that we landed off angle and roll in the final phase?
So I do see we had up to an 8-degree excursion. We're about to begin the roll maneuver, which is about
terminal phase.
The terminal phase, which is a large roll maneuver to get to landing attitude. That's the last data point I have. But up until that point, we were really solid.
Right. So terminal phase begins at 30 meters. Or post HDA.
Post HDA.
Post HDA.
400 meters.
Very good.
And that's a great conversation confirming.
That's good ground network, good for box scan. Make that go.
Yeah, that was good confirmation of the process that we were very familiar with, talking about the attitude of the lander, making sure that those antennas are within direct line of sight with Earth stations.
Another slim, not sure. But things are not looking good when they take this much of time. So
with our dishes to make sure that they're tuned in on our final landing site.
And now amateur radio astronomer observers are getting that they have lost the signal. So let's see. Let's hope that we are able to get the signal or not.
Dedicated to working these communications problems. It's been active this entire mission, and the largest, most powerful dish out of all of them is about a 64-meter dish in Australia. That time to search with that opportunity with the largest, most powerful dish, we're looking at about 12 to 13 hours after our estimated touchdown. So this is a process that we could be looking and searching for the lander's signal for confirmation for quite some time, but we're going to continue to listen in and stand by as our flight controllers are working working with the ground station in the United Kingdom to work this issue, work this problem. It's another challenge, very similarly to the challenge solved just to make it this far.
Signs of life, we have a return signal we're tracking.
Return signal? What does... Okay. Panic in the control room happened during Chandrayaan 2 also. Another Lunar 25. Lunar 25 is... no, it's not Lunar 25. This is another bare sheet or something like that in that category. Chandrayaan 2. Another Chandrayaan 2. You can see the panic in the mission control room now because basically
we have an onboard fault detection system for our communications that after 15 minutes with lack of communication will power cycle the radios, and then after that for another 15 minutes it will then switch antenna pairs. So we have some time here to evaluate. We do have signal that we're tracking, so we'll see what happens.
We do have signal.
There's a great call out about the autonomous systems installed on our NOVA-C class lunar lander named Odysseus. The process he's mentioning, Gary, is very similar to the one that we were preparing ourselves for at AOS, to where the lander has systems in place to recycle its antennas, to switch antenna pairs, and that was very similar to what we thought we were going to need to do after acquisition of signal. When we separated from the second stage of the launch vehicle, if we made it to a certain point, the lander was autonomously programmed to start taking matters into its own hands, and that was the information that our mission director, Dr.
We're not dead yet.
We are not dead yet.
We're
okay.
also not dead yet.
Okay. It's happening, guys. We are getting some signal. That's what they are saying. So, just give your best wishes.
And the key here, Josh, is patience. It's 5:34 p.m. Mission Director Tim Crane confirming that it could take 2 phases of 15-minute increments to confirm the status of the landing. So we could be here, and we'll stand by and monitor as NOVA Controls continues to work this issue.
Yeah, tense moments inside of mission control with the most qualified folks.
We're picking up a signal from our high-gain antenna and transmitter. It's faint, but it's there. So stand by, folks. We'll see what's happening here.
All right, we're going to continue to stand by. Let's keep this camera on inside of NOVA Control. It sounds like we are getting some kind of faint signal.
I want to send a series of commands to reactivate, make sure we're transmitting to keep the Aquasonics active.
Okay, this might be another slim. We don't know. The orientation might be a problem. As they said, right, the roll was a bit off during the landing time. That can cause issues because roll means you have to maintain a certain orientation when you are landing so that you can point your antennas towards the earth. So if that is messed up...
Still standing by. The last call from Mission Director Dr. Tim Crane was that we were getting a faint signal from Odysseus's high-gain antenna.
Some faint signal is there as observed by, as I said, we were getting some faint signals that amateur radio observers were telling about. So, but again, this could mean that it is not dead yet, but what's the state of the landing that we need to see? Whether it actually landed or toppled or what is it? That we need to see. And the 15-minute reset thing is basically they will do a sweep. Maybe Wildflower be able to properly explain. It's a military.
This is Mission Director on IM-1. We're evaluating how we can refine that signal and dial in the pointing for our dishes. What we can confirm, without a doubt, is our equipment is on the surface of the moon, and we are transmitting. So, congratulations, IM team. We'll see how much more we can get from that.
There you go. Okay, it's there. People are celebrating.
Excellent call from our mission director, Dr. Tim Crane.
IM-1.
And over
Go
to
for
our
Prime.
CEO, Steve Altemus.
Yeah, if I could just pass on a few words to the entire team in Intuitive Machines at Superbab and here in the Mission Control. What an astounding effort.
That was a tough
I know
ride.
this was a nail biter, but we are on the surface and we are transmitting. And welcome to the moon.
US is on the moon.
Houston, Odysseus has found his new home.
An excellent call, and this is our team of Intuitive Machines mechanics and their families, their friends, everyone who has sacrificed so much to make it this far.
US on the moon after 52 years. But again, we just need to see. As I said, Slim also landed just in a few weeks back. Slim also landed, but
How about
orientation
that
was
call,
an
Gary?
issue.
That was something else, a faint signal. Now it's time to work on refining that signal. But Dr. Tim Crane, our mission director today, making the call. Odysseus has a new home.
It shows the disciplines of the flight controllers in NOVA Control. They waited until there was absolute confirmation that there was a signal, and then that was when they took the moment to celebrate. We saw that it wasn't just the individuals in NOVA Control that contributed to the mission. The contributions to enable the success of NOVA-C's landing on the moon stretches far and wide. We showed, of course, some of the folks watching there, but really it extends even farther than this. A wonderful and truly amazing moment to celebrate. The U.S. has landed on the moon once again.
And to everyone, you mentioned it goes beyond just the folks that we saw on camera waiting and working through those tense moments, but their friends, their families, and everything it took to get to this point. We're still expecting an image. We expect that to come down sometime in the future, especially as we look towards some high-resolution images. Let's go ahead and it sounds like we do have a message we'd like to cut to. Can we have that message special for our folks, our employees, and folks watching at home?
Hey, that's right. With NOVA-C landing at Malapert A, congratulations, like you said,
Bro,
Josh,
they
are
have
flooding
landed.
into the teams that made this happen. Really sets a tone for the American
They have
leadership and
landed.
the future of a strong lunar economy. So here's NASA Administrator Bill Nelson.
They have landed, man.
On the 8th day of
Oh my God.
250,000-mile
They have
voyage,
landed. US is on the moon.
A voyage along the Great Cosmic Bridge from the launch pad at the Kennedy Space Center to the target of the south pole of the moon. A commercial lander named Odysseus, powered by a company called Intuitive Machines, launched upon a SpaceX rocket carrying a bounty of NASA scientific instruments and bearing the dream of a new adventure in science, innovation, and American leadership in space. Well, all of that aced the landing of a lifetime. Today, for the first time in more than a half century, the U.S. has returned to the moon. Today, for the first time in the history of humanity, a commercial company, an American company, launched and led the voyage up there. And today is a day that shows the power and promise of NASA's commercial partnerships. Congratulations to everyone involved in this great and daring quest at Intuitive Machines, SpaceX, and right here at NASA. What a triumph! Odysseus has taken the moon. This feat is a giant leap forward for all of humanity. Stay tuned.
Wow. Wow.
All right, thank you, Administrator Nelson. Again, NOVA-C and the United States has landed on...
They decided to play Nelson's message, so that means they have decided that it's a success. It might be a something related to Slim. Again, I am saying Slim also was a full success. Only the orientation was an issue. There might be the same case here also, but we need to see. We need to see.
NASA's CLPS initiative, visit nasa.gov/CLPS.
Gary, it's been quite a journey for all of us at Intuitive Machines. Thanks to NASA for the continued support to enable today's successful landing, and of course, everyone at Intuitive Machines, their friends and family who made all of this possible. That will wrap up our coverage of Intuitive Machines' IM-1 mission. Thanks for joining us.
Third person perspective, okay. Amazing, amazing, amazing. All right, all right, all right. Whoa, that was something. That was something. I'm telling you, that was something. US is on the moon. Well, well, well. I mean, you know, right, when you are having those things, but there was a comm outage. There was something which I still believe that there was some issue with the proper orientation which they were aiming for. But let's see how will they be able to do that. Congratulations to the fellow Eclipse company, an incredible achievement. What could have been the astrobotic first, but unfortunately, again, as I said in the beginning of the stream, we should not forget the sacrifices of those who have fallen, right? Same here. Astrobotic, I'm not sure whether they shared that information or not, but yeah, we have this thing. We do have a signal. That is what we were looking for. That was such a suspense. And finally, we have Intuitive Machines and US on the moon. Oh my God. Yes, this could have happened. This could have happened. We still okay. What I needed to see was eyes.nasa. Here I think we don't have that. It will be in that ESA's. I'm not sure what space network. Is track. But right now we are not having a signal over here. Basically this is not. It might not be tracking it. So Gold Hilly, I think that I'm not sure where that is. That station is. Okay, select station. I think it's in the Australia, right? But we don't have that station in here also. Okay. So I think they have decided that it has landed. Although on this one here, lunar, still we are not getting any signal on this thing. But since it's a faint signal, so we can't say anything about it. But yes, US is on the moon. US is on the moon. US is on the moon. That is what we are hearing. Let me see what anything have they tweeted out. Nope. Boone Hilly Station. That was the one, right? Where is it? Do we have a nope. Don't have a live something like that. Okay. Nope, nothing has been tweeted here. But yeah, I think that would make it. US is back on the moon. Yeah, there also. A very faint signal on 2250. They are also saying a faint signal is here. But yeah. Maybe it's a soft landing. I'm not sure the orientation, how is it? Because we are getting a signal, but it is very, very faint. Very, very faint. Are we getting something from him? No, no. Still have to wait for the proper, because the broadcast also cut off in between. Here you can see, right? This is what you want, what we all wanted to see. So this, I think, should be the confirmation. A very, very faint signal, but something is coming in. Here you can see the plot also in this waterfall. So that is the thing. So finally, after 52 long years, US is back on the moon. We are still not sure about the state of the spacecraft. How is it? I mean, they are still analyzing the data, but they are getting the signal. Similar to what Slim had, right? For the Slim lunar lander also, we were getting the signals, but the orientation was not so good. So the solar panels were not recharging in that case. And after a while, when the sun came onto the other direction, then they were able to get the power, then they were able to get the signal, and the overall the configurations, and some images also back from the moon. So that was amazing. So now US is again back on the moon. Space race is on. Yes, and yes, that's a good point you pointed out. Intuitive Machines is now the first private company to land something on the moon. Bearship tried, failed. Astrobotic tried, failed. Who else tried? From the Bearship, I think in private companies, these two only, right? Yeah. So now, guys, this is the thing. We have got a signal here. You can see US is back on the moon. Everyone is cheering up. And we got that signal, that speech from Nelson. So I think that should confirm it. That should be it. That we have landed on the moon. Yes, they have landed. Nice. Oh my God. Congratulations. Finally back on the moon. Seriously. US was trying for so long. I mean, space race is on for sure now. We are getting that, vibes. India went successful. China went successful. Russia has to join the race now. Lunar 25, not so much. But yes, US is on track now. It will be competing with China, as we all know it. And hopefully we will be able to get a positive outcome from that. Private launch provider also. Okay, nice. Yeah, previously Bearship was also launched by SpaceX, but it was not, but it did not land. So yeah, true. people have already got their edits ready, right? Where is that? I have not tweeted out anything. It was some, not this one.
As our equipment is on the surface of the moon, and we are transmitting. So, congratulations, IM team. We'll see how much more we can.
Yes, there you go. So guys, I think all right. Pardon me for that. Yeah. So US is on the moon. Space race is on. Who will claim the south pole of the moon? That is the biggest question right now. China is in the race, and that is the reason why US is in the race. China initiated the race, US came into the race. Other people are still, trying their best to be in that position. India is in the race. Chandrayaan 4 is already, plans have been devised and it's in the making basically. And it will be a sample return mission. So, an Artemis mission is already going on. Gaganyaan mission, again, India has also announced its plan to land people on the moon by 2040, I guess. Yeah, 2040. So, man, cis lunar economy. I knew that if US is successful, then US will be the actual and the main driving partner of the whole lunar economy and lunar exploration. And I'm so glad that they are finally back on the moon. This will not only push US to do their part, but also push China to do their part. And if China did their part, then also US will also try their best. And because of that, the humanity will win. No matter who wins this race, actually humanity will win. And after that, Mars is our next destination. We'll learn on the moon. We'll see how we can live in space. We'll see how we can do the things in space, how we can make fuels out of water in space, how we can again, as people, Elon Musk already said, right, the overpopulation is not a problem right now if we have space exploration, because if we have space exploration, we can colonize or send people out there, and we actually need a lot of people to do that. So, but again, there was some issues with the intuitive machines. It was not a smooth ride. It was full of bumps and roller coasters and speed breakers and whatnot. Initially, the first time during the launch, the issue happened. The cryo fuels were not able to load properly. There was some issues with that, so the launch got delayed. After that, the launch happened. It went smoothly, but after the launch, there is something called the spacecraft initiation, which was a problem. The star trackers, which is going to track the stars for the reference of its orientation and all, was having issues. It was not able to initiate. There was giving some faulty outputs or something was like that. But they solved it using their own what should I say, the software things. After that, there was no issues. Everything went smoothly. But in the lunar orbit, we got to know today only that yes, there was a delay for the lunar landing. And why? Because their laser finder, range finder is not working. I mean, if they did not have the NDL today, US would not have been on the moon. Just think about it. they will still have to figure out what happened with their instrument, why it did not work. NASA did they used the NASA's instrument. Now again, that is talking about the business point of view, right? That is something which you will kind of, I'm not sure how will you have a success criteria on this, because you landed on the moon but you use a third-party solution, right? Kind of like that. You did not use your own instruments which were supposed to do that, because next time when you will again go for the landing, that I don't think so NASA's NDL would be there, so they will have to perfect that laser altimeter. But again, that is a very, very small thing. They should be able to use that. We are having, so finally US is on the moon, and we are going to see people and astronauts going back to the moon again. Finally, congratulations USA, congratulations Intuitive Machines. I am just now, Odysseus has the new home. That is what is the, you know, what should I say, that dialogue, that significant dialogue. This will be the significant dialogue, right? After the eagle has landed, Odysseus has a new home. Although the operating time is just 7 days for this lander, so we need to see how it will perform. We will get some, I'm just excited for those images which will come. So yeah, you are not seeing this, right? So this is the thing which I was talking about. So Odysseus has a new home. So you guys, I mean, what I was saying, yeah, I am truly waiting for those images to come, those third person POV, the center of galaxy core image, the plume interaction with the lunar regolith. There are so many things, so many things are there. I am just waiting for everything to come back. Hopefully that will happen very soon. We just need to see what is the state of the lunar lander. Once we have that, that's it. Okay, James, let's have a good environment over here, right? All right. So Odysseus has a new home. People have tried their best to go to the moon, and now US has succeeded. Everything is as per the plan. So yeah, things are looking great. Do we have a signal over here? KPLO. So Max and NHPC not here. I'm not sure. The Goon Hilly station is something which we will not get right here. So, but yeah, okay. I think that should be it. It's 5:30 a.m. over here. So guys, if you really enjoyed the stream, do give it a thumbs up. And if you want to support me so that I can create more content for you guys, more information and more animations and more whatnot, just that is just on me. So you can become a Patreon or a member of this channel. It really helps in keeping this alive, because you know and now you will get more streams, because I'm hoping there won't be that much of my work will be there, office work. So US on the moon, China on the moon, India on the moon. I think Korea is also planning to be on there. So yeah. Are there currently satellites circling the moon which will photograph? Montero, that is a very good question. There are 2 satellites which are going to do that. NASA's own LRO, the Lunar Reconnaissance Orbiter, which is okay. But the main thing is Chandrayaan 2's orbiter, OHRC, optical high resolution camera of 0.5 meter resolution, which is the highest in the lunar orbit right now. That is by the ISRO's. So those two satellites are there, which hopefully will be going to get a photograph of the landing site. I know NASA will release it like that. I mean, whenever they'll take it, they'll release like that. But ISRO will take their sweet time. I'm not sure whether they will even be interested to photograph the landing site of the NOVA-C. Not sure. So let's see. Okay. Yeah. True, Naruto. I mean, the ISRO's data, which we saw on the live feed, that was amazing. One thing which was lacking for today's landing was the telemetry data. Even Slim has something for us to see, for us to analyze. If okay, this what they are saying is like it was successful, but again we did not get it. The telemetry, we did not get it. If it was not successful, then from the telemetry, we space enthusiasts would have figured out something. This would have happened, this would have happened, and our appetite for curiosity would have been quenched, right? But yeah, something is better than nothing. But yes, respect plus for again for ISRO. CH3 went so flawlessly, so smoothly. I mean, people are trying, still some or the other issue happens. CH3 zero, literal zero. Chandrayaan 3 literal zero issue, and it landed so phenomenally well. Such a textbook landing, and yeah. Landers from the private business ventures. Yes, Bubble. We are having a LUPEX mission. That's why the success of the H3 rocket was critical, because H3 rocket is going to take that LUPEX to the moon. But again, that LUPEX is hanging on a thread. It's just hanging on a thread, I'm telling you. Let's see what happens on that. But Chandrayaan 4 is going on, and China is also gearing up for, I think China is also like the Chang'e 6 is going to land on the south pole of the moon only, and China being China, they'll do something or the other which is going to be very what should I say, they will rotate our heads over it, right? Can you show your shirt? That is the same one which I wore on that. Okay. Here is it. Like this only. This is my lucky charm for the lunar landings. Chandrayaan 3, I wore this, it landed. Today's Intuitive Machines NOVA-C lander, wore this, landed. Now I will not destroy the luck of this sweatshirt. I will wear this in Chandrayaan 4 only, during the Chandrayaan 4 landing. Okay. It's 5:36 a.m. here. So thank you so much for tuning in. We will be having certain launches, which very soon. The next launch coming up will be of we might see a Chinese launch. When? Okay, tomorrow only. We'll see if I can stream that. I can get something out of it. It's on a very let's see. I hope I will be able to do that. Let's see. But flight 2 of RS1 is going to happen. Ooh. And the Soyuz 2.1A for what? Acha, sir, Earth Sciences. Feb 29th. Okay. Good. We have like a good amount of missions coming up. But yes, let's see. Tomorrow is a Chinese rocket launch from again, Chinese rocket launches are secretive, so I have to dig in with my sources to get something out of it. But yes, that is the thing. So thank you so much for tuning in, guys. Love you all, and I am so happy that US is on the moon again. Let's the space race begin. Let's see who among China, India, US, Russia would be able to conquer the south pole of the moon first. Yep, Jay Pratim. Thank you so much for tuning in. I hope you liked the stream. If you did, give it a thumbs up. And until then, this is Piyanshu Rohila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye-bye.